Hello and welcome everyone. Hi Stefano.
Hi, Alex. Welcome. How are you?
Yeah, that's a great day. I love all of
Yeah,
our Cassandra days.
yeah. And so this is the beginning of Cassandra Day, Australia, New Zealand. Welcome, everyone. It's going to be a long
Welcome.
day, a fun day.
We already have a lot of visitors.
Yeah,
That's amazing. Thank
and
you.
yeah, okay, very good.
Yes, so let me check a couple of things before we
Yeah,
start. If you can see us, if you can hear us, please set the thumbs up in the YouTube chat so we will know we can start.
yes. So
And
technical checks.
yes, some technical checks. Sound looks good. Streaming looks
Hello.
good. Looks like we are
Yeah.
connected well.
Ah, David is
Yeah, hi
there. Hi,
David.
David. Thanks for the thumbs up.
Thank you, David. Yeah, that's great. So, we are going to cover a lot of interesting things today. So, let's not wait and start. Welcome to Cassandra Day Australia in New Zealand. Cassandra Day is a series of events we run worldwide to help community of Apache Cassandra and related technologies grow and to help you be better in your skills as a developers, software engineers, administrators, DevOps engineers, whatever you are doing, mostly probably you need to have some databases running behind. And today we want to introduce you or upgrade your skills with one of the most powerful databases in the world. And as you could guess, that's going to be Apache Cassandra. So Cassandra is a very great database. Cassandra is used by famous companies all across the world, originally developed in Facebook to solve Facebook size problems. Now it's a top level of Apache Foundation, Apache Software Foundation, non-profit, non-commercial open source software foundation. It's a distributed, decentralized NoSQL database. That's a very special database which can give you a lot of power, but with a lot of power comes great responsibility. Okay, so why do companies over the world choose Cassandra? Cassandra is big data ready. Cassandra is ready to handle any amounts of information you want to give it. And to be a data-driven company, you need to have a lot of data. And Cassandra delivers highest level of the availability because of this distributed, decentralized nature. Linear scalability, geographical distribution, very high read-write performance. Well, read performance is not a surprise for many of the databases, but how Cassandra scales for write, it's one of the best features. And it's vendor independent. As said, it's its development guided by Apache Software Foundation. Who uses Apache Cassandra? There is a long list of the names, and you definitely know some of them. Netflix, Apple, Instagram, Alibaba, Huawei, Tencent, and so on and so forth. There are many users for Apache Cassandra, and mostly probably you already using it as a customer so far, or maybe already as an experienced developer, we will see. Uh, why Cassandra? First of all, because of the ability to scale out and handle problems of any size, of any performance requirements, of any volume requirements. So speaking of volume and velocity, it's like one of the databases what is very hard to beat. Apple reported it's already at DataStax Accelerate conference. What it has over 160,000 dedicated Apache Cassandra instances with hundreds of petabytes stored, handling multiple million operations per second. And for Netflix, those numbers are also very interesting because we run dozens, thousands of servers, having only on a single one of the clusters, we have multiple clusters, over 30 million operations per second. And that's a single cluster. That's an incredible number. So like those are going to be very hard to beat. For today, we will have two rooms. First room is more focused for the beginners. those who only start working with Apache Cassandra or desire to start. And second room with talks for a little bit more advanced people who already have Cassandra experience. So we can suggest what to do next. This is the workshop room. So if you are watching me right now, when you are in the workshop room, and that's what going to happen today. First, that's welcome and introduction going on right now. Next will be a very interesting keynote by Aaron Morton, field CTO at DataStax, and how it's about how data is eating the world and moving to the clouds. It's a very interesting one. I'm not going to miss it in no way. And I suggest you take a look at it too, because, well, there are many interesting things happening with data right now. Next one will be workshop Cassandra fundamentals. Step by step, we walk through the principal Cassandra features, and we get into how do you use it, why do you use it this way, not that way, and how to work with Cassandra in the right way. Also, it's a hands-on workshop, so you are going to stretch your fingers and click some buttons, and that is great because theory without practice is just dead knowledge. You have to push the buttons. When after a short break we will play the game, not like the Squid Game, but still with some prizes but no deaths, so our game is much better.
No penalties, only prizes.
Yeah. So we ask questions, you answer. If you do it fast enough and if you give right answers, you don't get punished. No, I'm kidding. You get the prizes. So then after that, a very special workshop which has a very special place in my heart, data modeling with Cassandra, led by Stefano Latini. The Cassandra power is incredible, but if you make a mistake with a data model, you are going to misuse it and you cannot get all the beauty of this database on your production clusters. So it's very important to have data model done right, and Stefano will teach you how do you do that. And then we have Ask Me Anything session with Cassandra experts. So very much recommended to ask your questions. By the way, we are collecting your questions during the sessions, and please ask questions not only on YouTube chat, but also following the link. Stefano, could you please?
Done.
Thank you so much. So ask questions using this link, because for the top rated questions or best questions picked by our experts, you will get prize again. And then finally, application development with Cassandra, done, I believe, by Stefano again. Right?
Yes.
Okay.
Very much right.
So you are going to be a busy guy today.
You too.
Good. And then in the end, closing words and goodbye. But that's not it, because we have second room. So talk room. We will have what's new in Apache Cassandra version 4. Cassandra community recently did a huge job delivering Cassandra version 4 with tremendous numbers of improvements, fixes, new features, and so on and so forth. Yoshi Kimoto will show what's new in Apache Cassandra version 4, what are the most interesting and promising features, why you should consider switching to Cassandra version 4 right now already. Then Paul Bremner from Instacluster goes for massively scalable real-time geospatial anomaly detection with Apache Cassandra. Paul is a great expert, and that is very interesting use case you want to take a look at. Then after break, there will be Cassandra or Apache Cassandra on Kubernetes with some steroids by Jonat Singh. Then later, Stargate.io, open source API layer for your Apache Cassandra. How to get more of your Cassandra installation with a couple of clicks. Very interesting. And finally, Apache Cassandra certification program by DataStax. If you don't know, mostly probably you don't, Apache Cassandra certification is a sponsored program by DataStax. So it's not free, it's not free, but we sponsor your education 100% with free online courses in this event, of course, and in the end with a voucher for the exam, and normal exam price is like $150 United States dollars, but with DataStax sponsorship you can get this exam for free, and you can join the community already as a skilled engineer. So I will explain there how do you get ready for Cassandra certification, what you need to learn, where do you need to learn it, and then how do you pass the certification. Special place, we will have a demo exam, not the real one, sorry, but we will have a demo exam right during the this talk. So you will see if you are ready already, or if you aren't ready and you have to learn more. And that's it for talk room.
Yeah, Alex, may I interrupt you for one
Sure.
important thing? We express all times here in this time zone, in this table, in this agenda for today. We express all times in the, you see, in the AEST time zone, which might be maybe not the best choice, but which means that so pay attention to the time you see on the table here, because that's maybe you have to do some conversion.
Yep. You see,
So,
as Cassandra Global V2, and this series of events was organized by people in Europe, far, far away. So
yeah.
I'm afraid it was our mistake to use this AES team, but we have what we have, so we proceed with this schedule.
Yeah.
Yep. Let's move on then. So highlights for the prizes. Let's play a game Cassandra quiz. But you don't have to be an expert, just attend our first session. That will be enough if you are a quick learner. And then Ask Me Anything sessions. Don't forget to submit your questions at datastax.io CDNZQA. Like, link is here and link is in the chat, I believe, already. And for certification voucher or Astro credit, if you are already certified, then you can go to CDANZ-voucher. Then, this event is organized and sponsored by DataStax developers, and our goal is to connect every developer in the world to the power of Apache Cassandra. But actually, I think our goal is a little bit wider, because that's not enough to connect every developer in the world to the power of Apache Cassandra. It's not SQLite, so you have to invest some time into your own education, and we help you to be skilled enough not to fail but to succeed. So Alex Voloshev, Stefan Alatini, developer advocates at DataStax, and a huge work also done by our APAC DA team, Jeremy Hanna, Niraj Naidu, Yoshi Komoto, and many other people supporting and baking this event, and many thanks to all of them, but first of all to you for joining. Practical remarks. Today content will remain available on YouTube channel. It's recorded and you can refer to it later. There are some links you will need, and you can always ask for them on YouTube chat. Don't forget, asking questions, don't forget your name, because we otherwise won't be able to connect with you for the prizes if you ask the best questions from our point of view. And reach out us on Discord. YouTube chat will be gone forever as stream is over, but Discord server will stay, and you can communicate with us there at datastax.io/discord. So if you are using Discord, we will be happy to connect with you there. See you at quiz session and 1:30. You get a badge if you complete the exercises and get the Cassandra Fundamentals Introduction to Cassandra workshop page. And bragging rights, of course, it's not the certification like a certification, but it's already something. You need to attend more than one workshop to get the certification. Okay, vouchers for the certification exam already mentioned. Don't forget to grab yours following this thing. and enjoy your day. Now we are switching for a moment to bring Aaron Morton on the screen with his talk about the data, how is it hitting the world, and why it's going to the cloud. That's going to be a lot of interesting.
Hi.
See you in a
Just
moment.
checking in. Okay, thank you. Hey, good morning, everyone. Good afternoon. I am, just make sure I'm in the right framing there. I'm coming to you from sunny Wellington today, and I'm going to talk about why I think data is eating the world and that it's moving to the cloud, and what that means for developers and engineers in your career. Before we do that, a little bit about myself. I'm from country Victoria. I grew up there, went to uni in Melbourne. In my mid-20s, packed a bag and went to London, lived there for 9 years, packed a bag and moved to Wellington, and I've been here for 12 years now. I started using Apache Cassandra at version 0.3. I am a committer on Cassandra. I'm on the project management committee, and I work at DataStax as field CTO, looking at how our customers can be successful with our technology. So for today's story, we are going to go all the way back to 2011. And this is coincidentally when I started being full-time on Cassandra. So way back in 2011, the top movies of the day were Captain America, the First Avenger, Hangover, and Harry Potter. It was a long time ago. But also in that year, there was an influential blog post from Mark Andrews entitled, "Why Software is Eating the World." Now, there was a really good blog post that made the case that software-based companies would take over the economy. That being software companies, they would be better able to scale, delight their customers, create new competitive advantages, and all of this would lead to high growth and high valuations. And I think it's been pretty obviously proved over the last 10 years that this was true. This was something that has happened. We're going to look through this blog post, but with a little bit of a different slant on it. We're going to look at the valuations and the growth of some of the companies that he mentions and understand their data use. Because this sentence really stuck out at me. So we're in the middle of a dramatic and broad technological and economic shift in which software companies are poised to take over large swathes of the economy. Well, we're here because we care about data. That's our thing. So in 10 years' time, will this statement also be true? We're in the middle of a dramatic and broad technological and economic shift in which data-driven companies are poised to take over large swathes of the economy. So let's go through the post, some of the examples that were in there, and understand what's happening today with these companies. So why is this happening now? Why can I now say that data is taking over the world? Well, Mark had a few reasons 10 years ago. Number one, and this one actually made me laugh, which was he said that software finally works, which kind of started to do back in 2011. and can be widely delivered at scale. Well, I'd say now this is true for data and for the data tools that we have, and they're ubiquitous. Back in 2010, we had the summer of NoSQL, where projects like Cassandra, React, Mongo all started to burst out on the scene in the open source world. And we moved away from legacy data incumbent providers who slowed us down. We now have 4.6 billion people using the internet. That's up from 2 billion in 2011. And that's 60% of the world's population. But of that, 4.32 billion access the internet on mobile, 90-something percent. Now, weirdly enough, as I was going through this post, back in 2011, Mark predicted that 5 billion people would have mobile access to the internet. And we're at 4.3 in 10 years. So we're at 4.3 now. So I think that was a pretty good prediction. And lastly, the cloud is now here for data. The cloud drove down the cost of running stateless workloads and made it more agile. You could just run your workload without having to go through provisioning. Well, we're doing that now for stateful workloads. The separation of compute and storage in analytical projects like Snowflake, Databricks, and in our transactional projects like DataStax Astra, DynamoDB, and some Microsoft products makes consumption-based pricing more attractive. That makes it easy to get started on a small scale, which is what cloud computing did for startups. And it makes it possible for large enterprises to collect lots of data without having to pay for the compute services if they're not using it. So let's look at some of the examples that we had. Netflix, pretty easy one. Originally, they crushed Blockbuster, and then they went after the traditional enterprise, the traditional entertainment such as Comcast, etc. So in the last 10 years, the Netflix capitalization has grown from 11 billion to 276 billion, 2,000 and something percent growth. The type of data they collect is not just what you watch, the time in the show, but the device you're on, how much you're pausing, do you come back and resume, and how much later? How long does it take you to finish watching a show? Do you repeat particular scenes and watch them again and again? And all of this viewer data is used to make recommendations. And over 75% of the viewer activity on Netflix is based off personalized recommendations. More than that, this is understanding users is core to what they do. In their published long-term view for investors, they say, by personalizing promotion of the right content to the right member, we have a large opportunity to promote our original content. One that's effective and unlimited in duration. I think there's two things to unpack here. They know what to make and they know who will like it. For a House of Cards, for example, they made 10 different trailers and then would show people the one that they thought would resonate the most with them, where you liked certain types of characters, certain ways that films were made. On the Spotify, and a company that I know very well, Netflix and Spotify coincidentally were early and continued users of Apache Cassandra. They used it to power their growth over the last 10 years. So Netflix grew over those 10 years from 1 million paid subscribers to 158 million, 356 million total users now. And the data they collect is a lot like Netflix, skips and listens and play counts and things like that. And then there's a lot of technology with that data that goes into creating the Discover playlist. They build a taste profile for every user. They look at the songs and the taste that they have, and they look at songs that appear in other users' playlists, and there's billions of those. And they use those, bring those together, and generate these Discover playlists that you get on a Monday. And in the first year that they were created, they generated 5 billion streams. So we looked at two major parts of two of the biggest, most ubiquitous companies that we have at the moment, Netflix and Spotify. They're all driven by the data they collect and their ability to process that and then use that. Let's try to understand the pattern that they're following. This is my pathway to a data-driven enterprise. Number one, instrumented every customer interaction and business process. How long did they go back and play that scene again and again? They'll know that, and they'll know that there are scenes that people react to. Next, let's look at Zynga. Well, not really. Let's look at Fortnite, because Zynga's still around, but Fortnite's a bit more interesting. And there's Zynga and Rovio were in the original article. They're still around, but Fortnite's more interesting. So they have 350 million registered users. They've hit a peak in December last year of 15.3 million concurrent users. And at a recent AWS event, they said they collect up to 125 million events per minute on the way that players are playing in the game. So this is how you play, how you interact with things, which other players you interact with. Do you just run around in circles and jump up and down? I've played Fortnite a few times with my kids, but not a whole lot, and I just run around in circles and jump up and down. That's my thing. They take all this and use that to drive the player matching for the battle royale teams, but they also use it to understand how to make changes in the gameplay. The game updates quite a lot. The features and the interactions and the gameplay are driven by the way the players interact with it by collecting this huge amount of data. And a natural extension of this was how they built AI bots in the game. So in the same way that Tesla collected a lot of data about driving and used that to build AI for driving, Fortnite have collected a lot of data about how players play and built AI bots. And then they released them last year, I think it was. And players started to think that they were surprised that they were doing so much better because they thought they were playing against humans, but they were really just bad AI, and they kept on winning. They're building a metaverse and using the data about how they interact, about how we interact with the game to drive that forward. Another use case here, LinkedIn. Growth, again, 131 million users up to 740 million users, and 555 million companies have their data in LinkedIn. They collect an enormous amount of data. If you don't know, LinkedIn is where Kafka came from. So they rely on Kafka a lot. It's 7 trillion messages a day running through Kafka. And this is things like the impressions, clicks, reactions, and comments, and shares, and follows, and all of the type of stuff that you do on LinkedIn now that it's become a lot more of a social network. And that data drives 4 large areas. It has the people you may know, your news feed, skills and recommendations, and the jobs you may be interested in. And LinkedIn have said that 50% of engagement comes from jobs you may be interested in. And then they give us some clues that say, hey, this is how you want to actually have a better experience. They say that you should write a good bio, get more skills endorsements, order them appropriately, make quality endorsements to other people, get lots of connections to utilize the network effect. So what they're saying is you have to, if you want a better experience, we need data. This is a data-driven experience. So what both of these companies are doing is collecting data on what happens and how. And that's an order of magnitude more once they've instrumented every process. And they're not just looking at the outcome of watching the TV show, they're looking at, or playing the game, they're looking at how I went about doing it. On the Instagram, I'm going to use Instagram as a stand-in for Flickr. Flickr is still around, but Instagram was, Instagram, again, a bit more interesting, a bit more data-driven. So they have 1 billion monthly users and 500 million daily users. And they collect all the information in the pattern that we've just discussed. How long did I spend on something? How did I engage with it? My follows and likes and comments and saves around different media that they have, photos, videos, stories, and live. And they collect this huge amount of data. And from that, they drive an AI platform that makes 90 million model predictions every second for their Explore section. This is actually taken from the Instagram engineering blog about how they power the Explore section. And half of their monthly users visit the Explore section. So they're using weak AI. So this is not Terminator AI. This is weak AI that's just making next best recommendations. It's saying, if you like this, you like that. sort of thing, but in a lot more complexity. If you go to the Instagram engineering blog, you'll see the level of complexity they use there to drive that through. So what are these guys doing? They're analyzing all that data and unlocking behaviors to drive next best actions using weak AI. Lastly, Starbucks. So in the article, it talks around, oh, and buying a coffee. It doesn't mention Starbucks in particular, but Starbucks is a data-driven company. I think it's important to understand this. So the market cap, again, is growing like everyone else's. They have 90 million sales a week worldwide. They have 13 million active app users. And so they know what people are buying, when and how and where, and what's going on at the point that they're buying that. So then that drives recommendations. If you walk into the store and it's a new store you've never been in, there might be something specific and that'll pop up on the app and tell you this store has something new that you've not seen. Or if you're going into your regular store, your order might be placed and they know that the baristas there know you and they'll get it ready for you. So their data is driving their customer experiences for 13 million active app users. And then they're making recommendations based on the time, weather, the location. Is there a holiday in your city? What was your past buying experience? Particularly the weather one, they talk about, well, when it gets hot, they'll promote the right type of drink for that area. They don't just use it for the customer experience, they use it for the business experiences. Decisions about store locations and menu items and where to actually place their stores and how to do real-time discounts. Everything at Starbucks is data-driven experience, the whole experience there. So that we can complete our pattern here. Step one, we've seen that companies are instrumenting every customer interaction and business process. Step two, they're collecting data on what happens and how it happens. Step three, they're analyzing that data to unlock behaviors and drive next best actions. And step four, they're using the next best actions to create fast, relevant, and personalized experiences and processes. I may just go into, there's only one Starbucks in Wellington, by the way, so this story doesn't work too well for me. But I may go into a Starbucks and most of the time I'm just the type of guy who gets the same thing all the time. But if I go in and I've got the app there and I'm keen to look around, they'll have the promotions there for me that they think I will be best suited to get. So what we've seen here is data is crucial to every company that's been successful at these large scales. And it's growing faster than most other areas of IT. We're going to look at some evidence for that and what it means for developers and that it's moving into the cloud. IDC IDC estimated that in 2020 we generated 64.2 zettabytes. That's 64.2 billion terabytes of data that was created or replicated. Nice that they put that in there because you want to replicate it around the world. And that's growing at 23% compound annually through to 2025. There is huge data growth because companies need data to be successful. Why do they need data to be successful? What is it that they're doing here? Well, data beats logic. This is pretty clear. These companies that are hugely successful, their experiences are driven by understanding the data. Data-driven experiences drive engagement and they capture users. And where is this data going? Or where does it belong? It belongs in the clouds. And I put plural there for clouds because there are public and private clouds and there are core and edge clouds. And we're going to see more of the core and edge clouds over the next 5 to 10 years as 5G really takes hold. And we're going to see as Kubernetes becomes even more dominant, that the idea of being able to move workloads, both compute and stateless, between public and private and across clouds in a hybrid multi-cloud environment is just going to become the standard way we do things. So I said that workload, that data was moving into public clouds. This is from the Flexera 2021 State of the Cloud report. Half of enterprises have workloads on the public cloud, and half of enterprises have data on the public cloud today. Half of enterprises are also considering moving sensitive data onto the public cloud as the security concerns have been overcome and dealt with, and that it's accepted that this is where you need to be to get access to the technology and the scale to actually execute on your business strategy. So what does this mean for you, the developer or the engineer or the architect or whatever it is? What advice can I give on that? You need to invest your precious time in a few areas. Kubernetes, because data belongs on Kubernetes. You will, if you're not now, you will be running things like Cassandra on Kubernetes on-prem. You may run your own Kubernetes on a public cloud and then run Cassandra in it, or you may be running it on like an elastic Kubernetes service, or you're using a service that's built on Kubernetes. But we are at the point where the data workloads work really well. We recently had a customer, there's a webinar coming up that I did with the CTO of Barracuda, where he moved on to DataStax Astra and only had 1 to 2 milliseconds difference in latency between their hand-managed, highly tuned on-prem Cassandra and running on Astra. And Astra is running on Kubernetes. APIs. I was around when Cassandra had a Thrift API, and then we worked out that was really not as great as we thought it was going to be. We added a CQL, a Cassandra Query Language API, and that's a great language, and it has become standard for NoSQL databases, with it being picked up by Microsoft and Amazon and a couple of other vendors who use it as a standard language. But multiple APIs so developers can talk to databases in the way that suits them most and integrates into their application stack the best is the way forward. APIs and gateways allow us to put more business rules and logic in between the client and the database. And GraphQL, I think, is one of the most exciting things we've got in tech at the moment. It is an awesome language. You should have a look at it. Support it with Astra. Understand what serverless and the separation of compute and storage means for you. Does it mean that you can go and experiment really easily because you can only pay for the operations and the data that you store without having to provision 3 servers or 6 servers to get started? Or if you're a large organization, what does it mean if you can collect a lot of data and store it and not have to pay that much overhead? You don't have to pay for all of the servers if you're putting it in a traditional distributed database. And then understand event-driven architectures and streaming and technology like Kafka and Pulsar. If we're in a microservice world, we've got a lot of microservices with dedicated databases behind them. How do we get that data out of there to drive this pattern that we've seen so that the data that's been captured in one system can be taken to another, merged in with other things, analyzed, and then you can take the results of that analysis and feed it back into the system of engagement. We're going to feed data between system of engagement, system of record, and system of analysis. I think those are the 4 great areas of the next year. And I think these are also great areas that you're going to hear about today. You're going to hear about Cassandra, which is Cassandra on Kubernetes. You're going to hear about APIs, which is Stargate. Then you're going to hear about serverless, which is Astra. And if you look at DataStax, you'll see some stuff on Apache Pulsar as well called Astra Streaming. That'll all come together for you. So thank you for your time today. I hope you get to learn a lot of interesting things as you're going through the workshops or the other talks today.
Good.
Hey, looks like we are back again.
Hey, La.
And that looks amazing. I see all the streaming settings are good, and you can hear us and you can see us, and that makes me absolutely happy. So we can go on. We have to cover a lot of very important things today. Meanwhile, Yoshi Kimoto started already in the second room with what's new in Cassandra version 4, what are the new features, improvements, and important things delivered in the version 4. But we start with Cassandra fundamentals. If you are Cassandra beginner but still interested in the upgrades of the recent version, then we suggest you first to join this workshop and then watch the recording of Cassandra version 4. And actually we have even a dedicated short course on Cassandra version 4 at datastax.com/dev. So there is also a lot of interesting and useful information for those who want to upgrade to version 4. But whatever, we have to start. So let me check if everything is good. Looks like everything is good. Let's start then. Thank you for joining. And we are going into a wonderful voyage. Welcome. So, Cassandra fundamentals, led by me with the great help of Stefano Latini. I am a developer advocate lead at DataStax, Apache Cassandra expert, tech lead, educator, architect, one of the Cassandra Days organizers, and a big fan of open source software. So, Cassandra, NoSQL distributed, decentralized database management system. Every word in this definition is very important, and soon you will see why. Main features that people picking Cassandra are: it's ready for data of any size, its incredible level of read-write performance, its scalability, what really matters, highest availability, self-healing and automation things, geographical distribution, platform agnosticism, I will explain in a moment, and vendor independent as a great feature for a database. So what does that all mean? First, big data ready. Cassandra is partitioned and distributed. That means this database is capable to handle data of any size, and we mean like petabyte scale. Apple uses Cassandra to handle hundreds petabytes of data, and there are companies would have even higher numbers in that. So, need more volume, add more nodes, as long as your data model is good. So don't miss the second workshop done by Stefano later on today. Read-write performance. Every single Cassandra node is highly performant, but a cluster consisting of multiple nodes and data centers brings throughput to the very next level. Decentralization, so masterless architecture, means what every node is able to deal with any request, read or write. So there is no things like passive nodes or read-only nodes. Every node is ready to deal with any request, is it read or write, any of them, even if there are thousands of them. Linear scalability. For volume or for velocity for output, there are no limitations. You need more, add more nodes. Linear is highly important word, like very important. There is no overhead on new nodes. It scales with your need. That means what, like with many other databases, scaling out, adding more nodes means what you also have some decreased improvement, and in the end, because of the overhead, you can add more and more nodes, but the performance boost won't be the same. Cassandra scales linearly. There was a great research by Netflix, which did in scaling Cassandra cluster from around 50 to up to 300 nodes to handle 1 million of queries per second. And they basically did a great job. By the way, if you are not subscribed to their Netflix tech blog, it's just incredible. It's for me always a fun source of very interesting data on how Netflix runs their infrastructure. So, but take a look. Here on this bottom line, we have number of servers. Here we have amount of operations and replication factor 3, which we'll discuss later. Take a look at this nice straight line. Isn't that amazing? What really matters for me is what this line is not degrade in the end. It goes straight, and that's a very, very, very cool feature. With one little mark, it requires proper data model. Yes, Stefano, I again refer to your workshop in a couple of hours. So,
Yes.
let's
It
go.
will be fun.
Definitely. And a lot of pizza.
Oh yeah, I
So,
like pizza.
highest availability, replication, decentralization, and topology-aware placement, data placement, take care of possible downtimes. There is no single point of failures because there are no master nodes. There are always multiple live replicas. Network topology-aware data placement is important because Cassandra consciously puts the data replicas as far from away from each other as possible to not keep all the eggs in one bucket, so to spread them over multiple multiple server racks or availability zones if you run in a cluster. And also on the client side with drivers, it's also very smart for smart reconnection and strong retry mechanisms. So basically then you run a multi-DC deployment with 3 data centers with replication factor 3 per data center. You are going to have overall 9 copies of the data, and that means what you can afford losing a lot of servers, still being highly available and dispatching your answers and storing your data successfully. So when I say, usually we say high availability. For Cassandra, I say highest. Self-healing and automation. Can you imagine manual operations on top of thousands and thousands and thousands servers when you have to do everything on your own? That is not going to be fun. Cassandra supports a high level of automation for operations and self-healing, which is very important for the many scenarios we will partially cover today. But this workshop is more for developers, so we focus more on development with Cassandra. Geographical distribution. So, okay, there is a Cassandra trademark, multi-data center deployments, granting you great capabilities to first keep your data close to your clients, because your clients don't love to wait. They love to have everything immediately, and if you are too slow and boring, they will just switch to your competitors, which is not nice to you. So, let's keep your data close to your clients so they can get their answers immediately. But also, meanwhile, we are getting disaster tolerance, not just fault tolerance, but real disaster tolerance. When one of the data centers in United States, for example, may be stolen by aliens, and our data centers still will be available. I don't know why United States one is stolen, but there is always something happening. So, all DCs are active. There is no thing like read-only or passive in Cassandra. All data centers are active. Now, platform agnostic. Cassandra is not bound to any platform or service provider, helping you build multi-cloud, hybrid cloud solutions and migrate from one platform to another if you feel so. There are some great databases built on the same ideas as Cassandra, for example, Google Cloud Bigtable. It's a good database. But with Bigtable, you are bound to Google Cloud, and you basically have no straight way to migrate to anywhere if you are not happy with Google anymore. And Cassandra is platform agnostic. You can have multiple data centers of the very same cluster working with different cloud providers. So your database will be multi-cloud or even hybrid cloud simultaneously, with some of data stored on your own data center or because of some legal reasons, and others will be on multiple platforms, and that's perfectly fine for Cassandra. Cassandra is free and not bound to any kind of a service provider. And also very important for me, Apache Cassandra is vendor independent. It was originally created by Facebook, but then contributed to Apache Software Foundation. You definitely know this organization already, or at least use its product, even if you don't know what does that mean. Apache Hadoop, Apache Spark, Apache Kafka, Apache Zookeeper, and many other projects people are using worldwide are all guided and collaborated by Apache Software Foundation and companies participating in their development. But there is no vendor lock and vendor dependency on Apache Cassandra. It's because Apache Software Foundation is a non-profit open source community. So, how it all works? First of all, first very thing we have to understand, data is distributed. What does that mean? That means we split data into parts, into partitions. Then you create a table. By the way, take a look at the screen. You can read and you can understand this statement. That's it. You just learned Cassandra query language. At least a significant part of it. Cassandra query language is designed to be very similar to SQL, so you can easily get it. Don't make a mistake, Cassandra is different to SQL databases. And you still have to learn a lot of things, but the community did a great job making it easier to learn. So, when we create a table, we must define so-called partition key. Here we see it's the first argument in the primary key statement. It's going to be a partition key. In this case, we create table users by city, and city will be this partitioning key. What does that mean? Take a look. You use it to the situation, then you have database, I don't know, whatever relational database you have, with a table. Then all the tables you have are copied to each and every server, like traditional approach. It sounds good and it works perfectly on small to medium data sizes. But then your data starts to grow, you get into troubles because basically there are some issues of the size. And then you have more and more data, they simply don't fit. And in this case, we go for partitioning. Take a look at the table on the right. Population by city, by country. For example, United States, New York, 8 million. Numbers approximate, doesn't matter. So, how does this store this table within distributed cluster? Very easy. We keep parts or partitions of this table onto different servers. Now notice a trick. When I created this table, I allocated this country column to be partition key. And now it leads to the creation of a new partition per country. Data is partitioned by country. That gives us a lot of power for scaling, for example. And it gives us one solid limitation. Any query without specifying partition key will be highly inefficient. Because now you don't know if I ask for some friends, like how many people in Paris, I specify France, I specify Paris, I get my data. But if in my query I do a stupid thing and just like how many people in Paris, first of all, we have multiple Parises in the world. Sorry, Cedric, but there are some more in United States. Not the same, I know, not the same. Then we have, basically, we don't know which server to ask. And we have to go and ask literally every server in the cluster, which may be fine if you have 3 servers. But if you have 3,000 or 300 or 3,000, that's obviously as stupid as it sounds. So remember, working with partitions, we need to know partition key when we ask for data, or when we store data, of course, we must have it too. But well, that must be quite obvious. Okay, so data is distributed. But how exactly data is distributed? Take a look. We have this partition key here by country. And it's going to be a string or integer or basically whatever, doesn't matter for me, but it will be hashed by murmur-free partitioner and throw out from a string value, in this case string for example, I will get a token, and token is always an integer. 59, 12, 12, 45, 45. So first, don't get it wrong. Normally those numbers are much longer. I'm just simplifying it a little bit. So, and now, as we converted values of this table into numbers, they call it tokens. We have a bunch of Cassandra nodes, let's say 4 nodes clusters, 4 nodes single DC cluster. And every server is responsible for the range of tokens known as token range. And then we can say what, okay, if every server is responsible for the range of tokens, we see, okay, Sydney, Australia, number 59, hey, you got here. So this data will be stored on this server. When Toronto and Montreal, 12, 12, you understand what's going on. This data will be stored on this server. And finally, Berlin and Nuremberg, 45, you go there. And fourth server stays like unloaded in this scenario, but usually we have much more data. Murmur-free is a very good hashing algorithm in this case because it gives very good even distribution of the numbers over whatever kinds of data you have. So, now, how it works when we scale, how Cassandra scales basically. Take a look. We have every server responsible for some range of tokens, from a minimum number to a maximum number. Again, that's not 1 and 100. Those numbers are much bigger. If I want to scale out and add more servers, I bring one more server into my data center, and Cassandra automatically recalculates token ranges and shuffles data to the new to the new server. So that means what every server has smaller token ranges and therefore smaller numbers of partitions it's responsible for. And then if I add more servers, again this token range length will decrease again and again, and each server will be responsible for less and less partitions. Quite opposite, if I'm going to scale in, so for example, Black Friday is over, or I'm Netflix, and I know what everyone has watched it already, last season of Squid Game or Game of Thrones, and people won't be using my service too much over the next couple of weeks. I can scale in to save my money on cloud costs, which can be tremendous on big numbers. And then again, what's going on? I tell Cassandra, okay, Cassandra, I'm going to decommission those 2 guys. We don't need them anymore. And Cassandra does what? Right, recalculate token ranges and transfers data to the proper servers. And boom, servers are decommissioned and I can take them down to save my money. It sounds good. Distribution is great, but not enough, because that's how we scale. But how do we keep high availability in this case? Data is not only distributed, but also data is replicated. That means when we create a key space is basically just a folder for your tables, like a box for your tables. When we create a key space, we must define replication factor per data center and replication strategy. So what does that mean? We create a key space, so we can create tables in it. We give it the name, well, quite obvious. And then there are a lot of settings, but 2 settings we must define: which strategy we will use and what will be replication factor per data center. With strategy, it's very simple. If you go for your laptop for some local development, for some testing environments, you just can go with simple strategy, and that's it. Simple strategy is good for your laptop and bad for anything else, because it's not production ready. It's just for very simple scenarios, just to test a couple of things. Then Second available strategy is network topology strategy. As you can guess from the name, it's network topology aware. So basically it considers network topology on how do you spread your data over your infrastructure. For example, you have a single DC, single data center, and in it you have 3 server racks, and you have replication factor 3. That means what every replica will be stored on a server in a different server rack, because servers within single server rack tend to fail together. Power outage, network outage, something else. You can lost single server because of a single server problems, but you also can get lost lost the whole server rack. Network topology strategy puts your data as far away from each other as possible. If we speak not about on-premises data center, but if we speak about cloud, in this case, it will be not obviously server racks, but availability zones. So you will have your data close, but not too close. That is important. And with replication factor, that's also interesting. Replication factor defines how many rows, or better to say partitions, are stored on different nodes. So basically, in this case, we have a data center of 6 servers and replication factor 3. It means what every partition will be stored 3 times on 3 different servers. How that works? When data arrives, first of all, server has to calculate its token. We see, hey, 59 Australia. Very good. I know what those 3 servers are responsible for storing this data. So in this case, they will be replica servers, replica nodes for this partition. Notice it's very important. Every node is a replica node, but just for this partition, those 3 are replicas. And for partition 33, for example, those 3 will be replicas. So replications defined per partition, right? And data is stored in this case, and that's how it works. Now, very important self-healing mechanism. If anything was wrong with one of our replica servers for this data, sorry, then the server what got your request notices what, hey, there is something wrong with this guy, and it stores so-called hint or hinted handoff. That means what data will be stored, and then the server recovers. It says like, okay, looks like I lost something. Sorry, guys, I was out. And then I just missed something maybe. And everyone who stored data for this failed server, recovered server already, will dispatch those hinted handoffs. So consistency will be recovered automatically, and you don't have to take care of that too much. That's self-healing. There are some limitations on this mechanism. We explain it in higher details in our operations course at the academy.datastax.com, which is, by the way, free. Let's proceed. Then how does multi-data center replication works? Considering we have 2 data centers in 2 different places, replication factor 3, then data arrives at first of them. Data will be spread asynchronously to the local data center and also dispatched to the remote data center. The remote query coordinator will put the data to a proper nodes. Now there is a question. Who is this guy remote coordinator? And who is this guy coordinator? Alex, you lied to us. Like you said, there are no masters, but now I see coordinators. It's the same, right? Wrong. In short, every server in the cluster is the one who gets the query, becomes the coordinator. Query coordinator for this query, so it will be responsible for dispatching data to a proper nodes. Another point, what if you have here the data, and if another server gets this data, for example, this one will get this query, it will be a query coordinator. So it's very easy. Use cases. For everything what belongs to scalability or high performance, high output, high volume, a lot of writes, a lot of reads, Cassandra is a very good choice. For availability, when you need your data to be available 100% of time, not like 99999, but 100% of time, you get your data stored and available for reading. For distributed data, for global presence or workload mobility. It's also a perfect scenario. For whatever your reason is, you can specify in which data centers you want to have data, in which data centers you don't want to have data, and per key space, and you have your data there, and in such amount you want to have. And of course, everything what belongs to cloud native. So modern cloud applications working on Kubernetes, working as an API layer over multiple clouds, and so on and so forth. That's all a perfect scenario for Cassandra. And I just wanted to answer a question from YouTube chat, but Eric, of course, did it already for us. Thank you, Eric. So let's move on. Now, you already could have guessed, replicating data, we get to the dangerous grounds because of possible cross-node inconsistency. And yes, you're right, it can be a problem, but there are some knobs and levers to push to keep your consistency under control. First of all, let's talk about CAP. And that's not about the cap, but about the data consistency. There is a great CAP theorem, or Eric Brewer's theorem, which stays for consistency, availability, and partition tolerance theorem. The trick of it, like you know the joke, job can be done quick, cheap, and in a good quality, but you can pick only two of those. Job cannot be done quick and in a good quality, but and cheap. Like it's not going to happen. It's going to be expensive if you want it right now and in a high quality. Same with the SAP theorem. You can decide and you can pick only two qualities out of three, let's say. What are the qualities we are talking? Consistency, availability, and partition tolerance. What does that mean? Let's start with availability. It's the easiest one to explain. Availability means you get the answer, right? Easy as that, you just get your answer. Enough. You ask your server, you ask your cluster, you get the answer. Not too much to explain. Consistency is different. And consistency in this case means whatever node you ask for data, you get always the most up-to-date value. You see, because of a network outages, power outages, whatever other problems, shark attack in data centers, one of your servers may not get the update. And if you ask multiple servers the same question, and some of them return most up-to-date value and some of them are outdated, it means they are not consistent. And finally, partition tolerance is the most misunderstood quality. I very often see people who not really realize what is it about. Partition tolerance is ability of the system to survive network partitioning between parts of the system. It means, what if you have a data center of 5 servers and normally they all can communicate and collaborate with each other, but then there is some network outage and you have your first group of servers within this DC, let's call it group A, and you have 2 more servers, let's call them group B, and they cannot communicate with each other. So group A is isolated from group B is isolated from group A, by both have access to the clients. That's called network partitioning. And there is an interesting point. Network partitioning can potentially lead to a split brain situation, which is way much worse than downtime. And now you can tell me, hey Alex, what can be worse than downtime? And I will tell you, network split brain Can indeed. What's the point? Story is, if part of your clients work with a group A and part of your clients work with a group B, you run into a really, really, really big problem, because if you don't have this partition tolerance, in the end you will end up having two different copies of a database, and good luck trying to solve and join them back together, unite them into a single copy, single version. You may think what downtime may be worse, but if after a couple of days of network partitioning of the big database, it will be just extremely hard, close to impossible, to merge data back into a single consistent version. And there is no way to automate it anyhow in the world. You will have to do it manually. So that's going to be a rough time.
Yeah.
Based on, you want to add something?
No, just it's a nightmare. When this happens,
Yeah.
it's really
Yeah.
a nightmare. So you better have other.
Yeah, it's really
problems.
better to be partially. It's really better
Unavailable,
to have partial
whatever.
outage.
Yeah.
So now remember CEP theorem. We can decide which qualities we want to have, but for real, there are only two places where we can be: available and partition tolerant. So we stay here, and consistent and partition tolerant. So we stay here. And the situation is looks like I do want to be consistent, but I also want to be available, and by no circumstances I want to drop partition tolerance. I have to be tolerable to network partitioning, which actually happens on the distributed networks no so rarely. And now people always ask, what Cassandra is CP or AP? And many people answer Cassandra is AP. Most people answer what Cassandra is AP, but I have a better answer for you. Cassandra is configurably consistent. Cassandra is tunably consistent. In any moment of the time, for any particular query, you can set consistency level you require to have. It defines how many confirmations you will wait before the response is dispatched. Take a look. With Cassandra, you have two knobs or levers, or how do you name them? Consistency level and replication factor. Replication factor defines amount of replicas per data center. And consistency level defines amount of confirmations from those replicas per query, and that is a very important thing. I will get back to that later. Take a look. When I execute the query, for example, like here in Java, always a lot of words, prepared statement, session prepare, insert into product, blah, 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 prepared statement, set consistency level 1. That will mean what I will wait only for one confirmation, what my data was stored out of a ref-free of free servers. You will see it soon. Also, I can work with consistency level using SQL shell, but we will skip that for now, and let's go and take a look on the consistency levels. There are multiple of them, and they basically all of them define the same. They answer two questions: how many confirmations I will have to wait, and what are the data centers I want to work with today. Now, for example, consistency level 1. When a query coordinator gets the data, it dispatches updates to all replica servers. Don't make a mistake. Consistency level 1 doesn't mean you dispatch data to only one single server. No, data is still being dispatched to all 3 replicas, of course. But when those servers get the data, they all answer, yeah, I got it, thank you. And we will wait for only one response. Who answer faster? Okay, one server got your data, and at this moment we confirm to the client what data was stored. Okay, we are good. Executed. Obviously, with consistency level Quorum. Quorum means majority, so more than half of the nodes. We will wait for a quorum of confirmations, and majority for replication factor 3 will be 2. Majority for replication factor 5 will be 3. And basically that means what with a consistency level quorum, we can afford losing a single node with replication factor 3 and still being fully consistent. Or you will see soon how do we go for that. And with replication factor 5, we can afford losing up to 2 nodes and still handling all the kind of queries we execute at the consistency level quorum. And finally, with the consistency level all, we will wait for the confirmation from all of the nodes. And now take a look. Now you can say, okay, I work with very important data. My clients don't want to have anything inconsistent. I'm going just to always use consistency level all, you may say. And there is a little problem. CEP theorem is still there, waiting for you. And it's going to make a strike when you don't expect. What does that mean? Then you go for consistency level all, you require to have full consistency. And what does that CEP theorem states and says to us? You can be consistent and partition tolerant, but you cannot be highly available. At the same time, you have to decide. So when you go for consistency level all, what happens if one of the servers is not available? You won't get your confirmation or you won't get your answer. And boom, Cassandra will answer, sorry, cannot reach desired consistency level. Better luck next time. Now, you can ask, okay then, I still want to have my data kind of consistent. I don't want to have it eventually consistent. I want it to be consistent, but I also need availability. How do I get in the middle? CEP theorem cruel Eric Brewer states it's not possible. Maybe you Cassandra guys can help me? Answer is yes, we can. There is a thing known as immediate consistency. The very right way to work with the data very often for the most of the scenarios is the immediate consistency. What does that mean? Let's take a look. Data center of 6 servers. Replication factor 3. So every partition is stored on 3 different servers. We write with consistency level quorum. We read with consistency level quorum. There are some scenarios. Let's take a look. I write with consistency level quorum. That means what I wait for 2 out of 3 answers. And those 2 guys answer it, and this one didn't. Now notice, we didn't know if it's really failed, or maybe that was a network luck and we just didn't get this answer. It may be updated, maybe not, but those 2 are updated for sure. Okay, now another client starts to read the very same data what was recently updated and read with a consistency level quorum. Okay, so we will wait for, in this case, we are lucky because query coordinator also will be replica for this request. Very good, actually it happened most of the time. And we will wait for 2 responses. And now take a look. We wait for 2 responses and there are 2 possible scenarios. We get first 2 answers from those servers what were updated for sure. In this case, answers will be the same and client will immediately get his answer. But there is a chance what this server will be this time faster, this one, and there are 2 possible scenarios here. It was updated or it wasn't updated. If it was updated, then everything goes successfully. Answers will match, client will get this answer, everyone is happy, everyone is laughing. But there is a possible scenario what this guy was not updated. What happens then? Take a look. Query coordinator has a very important job. It basically compares the answers and sees one has most up-to-date answer and one has outdated answer, what happens then? There are a simple story. First, client will get most up-to-date answer. And then query coordinator will initiate a repair for the failed outdated node for this partition. And query coordinator will say, hey man, you have outdated information, please fix it us up. And it will do a repair, grab data from the replicas what are good, and recover, and boom, we have all 3 servers recovered. And now guess what? It works automatically. So you will notice it happening only if you read the logs or if you have proper monitoring over your cluster. By the way, sometimes occasional repairs is good. I mean, like, shit happens, everyone understands. But if you have too high level of repairs, repair reads happening on your cluster, you may want to consider like to check what's going on, because under normal circumstances that's not fun, that's not nice when you have too much of repairs going on, like for something wrong with the network, probably something you have to fix. Good. Few more words I wanted to say about that. We discussed about the numbers, and now you can understand 1, 2, 3 quorum all. But what does mean local and what does mean each? First of all, it's a very simple story. If I have multiple data centers, like in this case, and I specify each quorum and I work with highly important data, I want my data to be absolutely sure delivered to every data center 100%. Then I can require consistency level each quorum, and I will wait for every quorum of every data center to confirm what they got the data. Good news, I always know what data was delivered to all of the data center. Bad news, if you have data centers in Australia, Europe, United States, and I don't know, whatever else, Norway, why not? Then that's obviously not going to be as fast as a single data center query, right? So each quorum has some costs. What's more often used is local quorum, and local quorum means what? Take a look. If you have data centers in Australia, United States, and Europe, then mostly probably you have also your application servers running in Australia, United States, and Europe. Do you work your European application server to work with your Australian database server? I guess you don't. Then my point here will be, when application server starts, it knows which database, which data center will be considered as local or as closest to itself. And then a request to work with local quorum means what? European application server will work with European database and expect for quorum only from one single DC which is closer to it, giving highest possible performance. As you see, there is quite a lot of things to configure with Cassandra, giving you the power to keep your data and consistency under control. Okay, yeah, by the way, getting back to the immediate consistency, there is that's basically mathematics. If your consistency level write plus consistency level read higher than replication factor, you have immediate consistency no matter what. Consistency trade-offs are obvious. Higher the consistency level, lesser chance you may get stale data, but you pay for this with possible latency. Notice the possible part. If your network works good, if your servers are not overloaded, most of them answer within more or less the same time. But obviously, the more servers you wait for, higher chance what one of them will be in some busy, some delay, getting out with friends, I don't know, but it may take longer if you wait for longer, bigger number of servers. By the way, that's one of the reasons we usually don't recommend to go with replication factor on numbers higher than 3, like 3 is a typical recommendation per data center. For some kind of use cases, especially with very write-heavy workloads, they may benefit from a lower consistency level, like getting to consistency level 1, for example, if data is not required immediately and your system works in a stable way. You can write with consistency level 1, and then if you're not going to read this data immediately, anyway it will be recovered, or in good scenario it will be delivered immediately. In worst scenario it will be delivered via hinted handoffs or repairs. But the general idea is consistency level 1 indeed can be dangerous. And if some of your servers wasn't updated, like in this example, if you ask with consistency level 1 and get to this bad guy, you will get stale data. So consider consistency level as a very important knob or lever or whatever you prefer to call. Good. Are we have any good questions maybe?
There are no particular questions. There was one, but we answered that in the chat, and that was a few minutes ago, about using more than one column for the partition key.
Good question.
And yeah, so that's absolutely permitted, and it's actually a very common pattern to define more than one column in the partition key. And in that case, every single partition is specified by the whole set of values for all columns. So again, if you want to specify a single partition, which is what you usually want to do to reach a single node, a single partition, you have to specify the values for all columns. So if you just give the value, say, of the first column, that's not yet enough to go to a single node in general.
Right. Yeah. Thank you for a good question, but sorry, stupid me. We have Stefano and Eric in the chat. Obviously, all questions are answered already.
Yeah,
Okay.
But some question is good to bring to the attention of everyone, because they might shed light on some points that we necessarily have to just, go quickly through.
Right. Good. So, data. How data is structured in Cassandra. First, Cassandra is a tabular system, so you're going to work with the tables, as you could have guessed already. It all starts with a cell, and cell must be familiar at this moment. It's an intersection of a row in a column. It stores data. Sounds quite obvious. Then, row. Row is a single structured data item in the table, keeping some cells. So far, so good. Now there is a new thing. Partition. Partition is a group of rows having the same partition token. It is the base unit of access in Cassandra. And that is a very important point you don't want to miss. Partitions are the base unit of access, and it's the core thing in Cassandra. And there is a trap that many people get in traditional relational databases. You have tables, you have columns and rows. There are some partitions. Oh, they don't matter. I will go and use Cassandra as MySQL without joins. Cassandra is great, people say, so it will work perfectly for me. Sounds good? Doesn't work. Cassandra highest performance and all the other cool things are the shared responsibility. Cassandra gives you the tools, but you have to use them in the right way. If you don't know how to use the hammer and you will hit yourself in your leg, it's not the hammer's fault, right? It's your fault. You have to learn how to use your tools. And the easiest way to get into troubles with Cassandra is to misunderstood or underestimate the importance of the partitions. Don't be like that, be better than that. Partitions are very important, and partition is the unit of access in Cassandra, not the traditional row. Row is just a part of the partition. Then basically a table is a group of columns and rows storing partitions, and that must be quite familiar. Then you create a table in Cassandra query language. You have to define some things. Key space, which is a folder or group of tables, right? Table, users by city. Okay, then there are some column definitions. City, last name, first name, address, email. In this example, they have all data type text, but believe me, we have more than one data type, of course. And then finally, we define primary key. Primary key consists of partition key, which you know already, and clustering column. Let's walk through the definitions. So, primary key. Primary key is an identifier for the row. It consists of partition key and optional clustering columns. Partition key must present. Clustering columns are optional. You may need them, you may not need them, depending on. Good example. Well, why not? City, last name, first name, email. City will be partitioned for users by city. And last name, first name, email are parts. We need parts of a primary key. Take a look. Why this example for the same table, city, last name, first name, is not good? Why is it a bad example? Answer is simple. I believe some of you may notice it already. There can be a lot of John Smiths in New York. That's for sure. And every next one will give give quite a bad surprise to the previous one. So we add email to have this row unique. So we will have multiple different John Smiths, not a single one per city. So this will perfectly work. Partition key, we already discussed it. Partition key is an identifier for a partition. It consists of at least one column, may have more if needed. It partitions rows into partitions. For example, like a typical example, you have YouTube. On YouTube you have videos. Of videos you have comments. It very may make sense to have comments partitioned by videos. So each video will have one single partition for its comments, and it will be perfectly operational. Sometimes we want to have single row partitions, which is also perfectly fine. If we don't need to search users by last name, first name, for example, we can just go for user ID, and we will have a table of table of as much partitions as many rows, because a single row per partition. It's also fine if it suits your data model, which will be later explained by Stefano. With clustering columns. Clustering columns, they have two duties. First, we use clustering columns to ensure uniqueness per row. Very much makes sense, as already explained. City, last name, first name may need email to guarantee uniqueness. They also needed to establish sorting order because data in the table are sorted based on the clustering column. A very important point. And finally, clustering column has one more duty because partition key and clustering columns, so all the parts of a primary key are kinda primary indexes. So you can search and sort data by them with some limitations, and be very fine with that, and it all works. But notice very important thing, by the way. By non-primary columns, so not partition, non-clustering columns, in this example it's basically going to be only the address. You cannot search if they are not in primary key, and that is a very important limitation. You may search only by partition key and clustering columns. In this case, address is a data column, and data column, in order to search by it, you will need a secondary index on that, and secondary index is a very different story, which again will be explained in the data model part. So we better go with this scenario, searching and understanding how do we work with partition key and clustering column. Now, those are the most important slides of a presentation. And if you can take screenshots, get the screenshots, because it may change your life. Really, it may save your life at some point. So, partition is the base unit of access. If you fail to design your partition properly, you will have some problems with your data, and you will have some problems with your cluster, and definitely you may have some problems with scalability. But good thing, it's not so hard to design partitions properly. There are basically 3 primary rules you have to follow. I call them rules of a good partition. And if you see this slide of a year award, I created those slides and I gave them this award because I believe they are the most important slides you will see within this year. So, first, store together what you retrieve together. Example, you open a video on YouTube, or your client opens a video on your YouTube, whatever it is. We want to show comments to this video. And we don't want to ask dozens servers for those comments. We want to ask one single server. And then obviously we can partition our data like that. Primary key, video ID, created at comment ID. Let's take a look at this example. First, we partition it by video ID. All the comments will have, all the comments to the same video will have the same video ID. That means what we will have a partition with all those comments together, stored together, what you retrieve together. You have to load last 200 comments, single query to a single server. Very good. Now, created at. We needed to have our data sorted by time, so comments will be already sorted and I will get them most recent first. And then finally, I have comment ID here just to ensure uniqueness, because obviously comments per video at the same time may be created by 2 different people. So on big numbers, this collision is inevitable. So I add comment ID for the uniqueness. Now let's take a look why this design is wrong. Comment ID created at. Comment ID will be partition key, right? And as I told you in the beginning, if you don't specify your partition key, your query is going to visit every server in your data center and ask, maybe you have a data for me, and that is as stupid as it sounds. I don't know about you, but then I order pizza, I give the full address to the delivery boy, not just half address, right? And it's the same with Cassandra, you better give the full address. It's just like much better to one who is going to bring pizza to him. So, okay then, and with this one, how am I going to load all the comments per video? That just won't work. So, second rule, very important rule, avoid big partitions. And that is very important. What is a big partition? If data distribution is not even, if one partition is noticeably bigger than the others, it's still maybe not so bad, although it is bad, but then your partitions grows too big, and that's getting hard for the server to handle them. That's definitely going to slow things down. There are only one hard limit, up to 2 billion cells per partition. But we recommend you not to get close to this limit, because you will run into problems significantly earlier when you reach it. Our recommendation, up to 100,000 rows in a partition. You may go higher, but those are already dangerous grounds, not recommended. And our recommendation is up to 100 megabytes of data in a partition. Again, those are not hard limits, it's flexible, but still some reasonable limits. I know one of our clients had once, we found out a partition of 1.2 terabytes of data. As you can imagine, that's not going to work fast, and that's not really going to scale. So understand size of a partition. And that is a very, very, very important thing. One more thing is take a look. One hidden danger, like some people get into the trap here. Imagine a huge telecommunication company. Hardware all over the world, multiple data centers everywhere. And they need to understand what's going on. So they have different sensors reporting their state every 10 seconds. Every sensor reports its ID, timestamp, and sensor value. So the data structure is simple. ID of the sensor, UUID, like the long ID, timestamp, and value. A value can be different and can be temperature, it can be humidity in the room, it can be current network output, and so on. So there are different kinds of sensors, but it's still just some value of a report. And in the beginning, we decided to design our system like that. Primary key, sensor ID, store together what you retrieve together, and reported at. So data will be sorted by time. Uniqueness guaranteed at the time level. In this case, will be enough because all sensors have different IDs. Now let's take a look. In the beginning, this approach worked well and everything went good and everything was shiny. But when, after some time, something bad happened, and something like really bad happened, and cluster performance was heavily degraded, and many other problems. What happened and why? Let's play a true detective, a true IT detective, and find out who is the murderer. What happened in this scenario and why things went wrong? Please write your answer on the YouTube chat, and I will drink my coffee and think. We need some music here, like you usually have in thrillers. Who is the murderer? What went wrong? Try to guess. You won't get a prize for this answer, but you will get my personal respect, which is quite a lot. Meanwhile, Stefano, if we have some good questions there, you may want to prepare them to read out aloud. I know we have little delay between real translation to YouTube, but the data keeps growing, right? And like you have the clue, but now find the criminal. Data keeps growing and what? Too many records coming in for a sensor. No, that's not a problem. If you mean from the scale point of view, as long as you have enough servers to handle all the right operations, and Cassandra servers are very performant, amount of records coming in for a sensor, like per second or per moment of a time, it's not really big problem. Yes, finally. That is the final answer. Partition size will be huge. One very important notice,
Alex,
yes.
may I say one thing?
Yes,
C#
sure.
guy says too many records coming in for a sensor. So the right answer is implied there.
Okay.
So C# guy, yes. And yeah. So
good.
The right answer is implied there, but yes.
Yes.
Good.
And that is the problem. Right. We will have, in the beginning, it all will be good, but overall, we will have two big partitions over some time. There are two scenarios to solve this problem. First one, call it TTL. TTL is time to leave. And basically, that's a really cool feature of Cassandra. Then you create a record, you can assign a TTL to it, time to live. Even then you create a specific value, what's even more interesting for some cases. You can create a TTL for it and say like, okay, you are going to disappear after some time, after a month, for example, and then table will be cleared. That's a great thing, but it's not always what you want. In this particular example, that's a real life example, by the way. Company didn't want to have this data deleted. They wanted to keep it over many years. In this case, we introduce a different solution called bucketing. What is a bucketing? Idea of very simple. You remember this question in the beginning? Sensor ID, month, year. Now we introduce one more field in the partition key. And you may ask, what is the month, year? It's never reported by the sensor. And we cannot upgrade all the sensors in the world. It's going to take years. Right. Month, year is a synthetic value. We just get the current month and current year. So that's the October of 2021. And month, year is going to be 102021. Then October is over and November starts. It will be, guess what? 112021. And boom, we have an automatically created new partition, and data always will be stored in a new partition. So, month, year can be integer or a string, that doesn't really matter. And this way we'll have buckets. And every sensor writes to a partition till the month is over and then starts to write to a new partition. Yeah, oh, thank you, Stefano. So yes, it can be like that. It's generated from reported at. There is no actual information. That is a bucketing to split your data into multiple buckets. Now, some of you may say, why do we introduce a month, year? Why cannot we use just like timestamp, date, time, day, week, hour? So we will have even smaller partitions. Smaller partitions are good. Yes? The answer is we take a look. We have to avoid big partitions, but we also have to store together what you retrieve together. And if sorry, Stefano, may I ask you to mute your keyboard? Yep.
Yes.
Sorry. No worries. So let's take a look. Don't forget, when you query for data, you have to specify all the parts of the partition key, right? And if I query for data, for example, for last 3 months, how will my query look for this design? So I'm going to show the graph of the temperatures in the server room number 12. Answer is it will be look like select all or select whatever I need from table name where sensor ID equals 1 to 3 and month, year equals to 10 2021, 9 2021, 8 2021, 08, 09 and 10. So it will be simple in statement in, and then there is a list of values. And will it be the perfect query? Well, it wouldn't be the perfect one, because perfect query is a query which reaches out for one particular partition. In this case, we will have to hit 3 different partitions, which is not the best, but which is acceptable. But if I have smaller partitions, weekly or hourly or minutely, can you imagine how my query will look like if I'm going to query data for the last 3 months? I will have to specify every minute of the last 3 months. That will be obviously not the best way to work with a database. So that must be quite obvious. Good. And final thing, are there any good questions
Well, there was some discussion in the chat about this idea of adding month year, and yeah. So Krishna and asked why cannot we just use sensor ID? It is unique. Yes, it is unique. But now the point is to avoid having a partition that grows and grows and grows as the months go by, which at some point makes for an unmanageable partition eventually. So now the point is to split the partition in manageable partitions. Yeah, so that's it.
Good.
Then I've seen a few questions earlier that I also see in the Q&A collection, so we might save them for then, so to have time to discuss them more in detail. So please stay tuned, because in the Q&A session, we will have a bit of discussion in the chat with you if you ask the question, so we can maybe go much more in detail. Yes. So I think for now, that's fine to go ahead. Yeah.
Yes, and there is a very good point. So basically, we create the partition key depending on what we need from it. Right. Exactly.
I love seeing such a remark in the chat. That's exactly it.
Yes, and now there is a second point. Being a global IoT, I would prefer a region country partition. Take a look. It may make sense, or there may be better strategies. So it's always very depending on the use case, on the scenario you have. So it may vary. So it's not... there is no silver bullet. There are always some considerations you have to understand, and country or region-based partitioning may make sense, but it's not like the single, only one-size-fits-all solution. No.
Sorry, Alex, may I stop you for a second? There is a very interesting comment in the chat. Balaji says, it looks like the data is stored as rows and columns. Then how is it NoSQL database? I think this point is very dear to you and to us all. So, okay, now seriously. Do you want to say something on this, Alex?
Yes, sure.
Just 2 words, because that would open a longer, but I know you love this point. So,
you know what? Recently, well, you know about that. That's for our attendees. Yeah. Recently, I did a talk. NoSQL doesn't exist, and despite its provocational name, there are indeed some proofs, and I can prove what NoSQL does not exist. I have to. The problem is this talk was in Russian, so I have to do it again in English. For the wider audience. And the idea is NoSQL. If I will ask our dear Balaj team if NoSQL is schemaless, mostly probably he will answer yes. By the way, Balaj, if you may answer this question, do you think what NoSQL is schemaless? Please answer it in the YouTube chat. It will be interesting.
Well, now, maybe everybody can answer if they want. Yeah, so is NoSQL schemaless or not?
Yeah,
thank you for... Is it schemaful or not?
Yep.
That's an interesting question. Not only.
Hey, that is good. The applause, like that is good. So the answer is there are over 200 of different NoSQL databases. And they are very, 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 very different even to each other. And some of them are much far away, much more away from... Oh, okay. So maybe it is not schemaless. That's the right answer.
Yeah, we have good answers.
Those are good answers, right. So take a look. There are key value databases. There are graph databases. There are ledger databases. There are navigational databases. There are columnar but no relational databases, and so on and so forth and so on and so forth. And they are very different to each other. Trying to group them together into NoSQL, we're doing actually a bad work, because some of them are much far away from each other when from to MySQL, or I mean any SQL database. So idea is, don't think of NoSQL as a single monolith. There are graph databases, those are much more relational than relational databases, because they really care about the relations of the entities. NoSQL is not about tables. There are many NoSQL bases based on columns and rows, and that's perfectly fine. NoSQL is about usually missing SQL, which is also not always true. And the idea is NoSQL means not only SQL, so all the other databases except of SQL. And obviously Cassandra is not the SQL database. And it can be schemaless for Cassandra, it can be, schema full for Cassandra, it can be schemaless for some other databases, doesn't matter. If it has schemaless, then how it's maintained across the cluster. We cannot get too deep in this question because we have more topics to cover. But let's get to Ask Me Anything session. It will be interesting.
Okay, so I just want to do a very short remark because back to biologity question, that's very interesting. So how come it is table-based? It is a column database, but it is NoSQL. Now, I had the privilege of attending Alex's Alex seminar about NoSQL does not exist, which I enjoyed a lot. It's very funny, lightning talk and funny. And so, okay, a small side remark. I love invertebrate biology. But now, if you think about that, invertebrates is the same thing as NoSQL. So there is no trait shared by invertebrates except being not vertebrates. So they don't have bones. And the same for NoSQL. NoSQL databases do not necessarily have any common trait except that of not being SQL databases, not being relational. So in that sense, NoSQL is a misleading label, let me say. And there are all sorts of NoSQL databases, all sorts of invertebrate animals. Okay, sorry, that was just to have a little fun.
No. Yeah, thank you so much. That's quite cool. And final thing, again, there is a key value database like Redis. There is a graph database like DataStax Enterprise Graph or Neo4j or AWS Neptune. And they are absolutely different. And like NoSQL is a very interesting place. Okay, finally. Avoid hot partitions. Sorry, Stefano, could you please switch off? Yeah, thank you. So, avoid hot partitions. What does that mean, avoid hot partitions? What does that mean, hot partition, first of all? Take a look. When one of your partitions are being accessed all the time, while others aren't, it's not a big deal. But then your partition is being accessed all the time on a huge scale, like with really a lot requests per second, more than a single server can handle, then you are in the problems. Sorry, Stefano, you are not muted. Yep. Take a look. Why do we do partitioning after all? To have some isolated data chunks for scalability purposes. Then one chunk is getting too big, it is bad. It's not scalable and so on and so forth. And one chunk is being accessed all the time, while others are not touched. It is bad, then it's accessed too much. If there would be multiple smaller partitions, we can scale out, add more servers, these partitions being moved to new servers, and it's scaled. But if you have this point of databases, if you have this one single partition of too big, like imagine you have you are an e-commerce company, you are selling some goods, and you have like couple of hundreds customers in one country, 2,000 customers in another country, and then surprisingly you start to sell in China, and everyone in China is excited about your goods and buy something from you. And you have your customers grouped by country, which may look good in the beginning, but let's take a look. Now we have one partition which is being accessed all the time, overloaded. Servers are just on fire and overloaded. And there are some other partitions, those are minor and not really accessed all the time like that. You can tell me, hey, we just got a huge success in China. We can add more servers to the cluster. You say it perfectly works for Cassandra. And answer is, let's take a look. Let's say we have 10 servers, replication factor 3. Our overloaded hot partition is located on 3 of them. We add 10 more servers. That will lead to token ranges recalculation and shuffling some of the data, right? Okay, good. So amount of partitions per server will decrease. But this huge partition doesn't disappear. If the pressure on the partition is too high what a single server can maintain it, then obviously you can add as much servers as you want. That won't help. You can add 1,000 servers, you still have overloaded partition, because the partition is the base unsplittable unit of access. So you have to think about that some partitions may be also overloaded, and they have to keep them in smaller chunks because it scales much better than bigger chunks. And that's why we recommend to keep partitions smaller, so it will be easier to scale. And that's a very important thing to understand. Okay, Stefano, looks like it's your time.
Very good. Okay,
so should I switch to your screen?
Maybe yes, because you just have this slide about lab. Maybe there is another slide with the URL, but I'll grab it from here. So
I'm showing it right now.
Okay, so very good.
Yes.
Okay.
So practical materials are available at github.com, DataStax Devs,
very good.
Workshop Intro to Cassandra. And now there is important part. Take a look. Cassandra maintenance and operations is not so simple thing. If you want to have with multiple instances cluster, you're going to do quite a lot of work. But you know what? We love you, so we already did this work for you. It's called Astra. Astra is a Cassandra-based database as a service. So you can simply create your instance at astra.dev/Cassandra-anz and get your cluster right now for free. And you can use it even up to small production workloads and definitely for educational purposes for free since today and forever. So enjoy your free tier at Astra from DataStax, and we will use it for the lab work with Stefano. So I'm switching to your screen, right?
Yes, go ahead. I'm here.
You are live.
Okay, very good. So welcome to the practice part of today's Core Cassandra talk, or workshop better. As usual, Alex, I remind you that I'm not seeing the YouTube chat anymore, so you will have to help me looking what happens and checking for, the thumbs up and everything. So, okay, so what are we about to do? We will play a bit with Cassandra. Well, we will play a bit with AstraDB, which is a database built on Apache Cassandra that is available for you on the cloud, managed by us, free to use, and up to a very high level of usage of storage and transactions. And, well, let's start by doing, and then we will see a bit how it works. So I pasted 2 links in the chat. One is the link to this page where you will have to register for free to AstraDB. AstraDB, as Alex said, is offered for free by DataStax. and will give you the possibility to play with basically a Cassandra installation, or it's built on Cassandra, without having to manage the database. So please, you should register either with GitHub or Google to sign in, or you can register with name and email and password and everything. You will be then creating your account, as you see here. Obviously, I have already my account, so I will pretend I registered like you probably are doing. And okay, so I've been logged out. Give me 1 second. You will never guess my password. Indeed, I typed it wrong. Don't know why. I think my token expired now. Okay, sorry. So after registering and signing up, you will end up with a similar interface as you're seeing now, except you will probably directly be brought to a create database screen like this one, because as soon as you register, you will directly go to a page asking you to create a database. Now, another link that I gave you is the link to this GitHub repository. This contains instructions to play with the database. We will basically follow these instructions, but these instructions contain everything for you to be able to work wherever you want, even later, even by yourself. So it's all explained. So please keep in mind that you can also go later on that. And an important thing is that these exercises contain a homework, as you see here. So there is a small description on what you will have to do as homework, which basically is completing what we are doing now, plus taking two small courses, and I will show them immediately. After which you take a few screenshots and submit them as GitHub issues. Why do you want to do that? Because then, as we mentioned in the beginning of this morning, you will be given a badge that you will be able to use to brag around and, make envy in your friends. So, no, okay, I'm joking, but if you complete the homework, you will get a badge, and that testifies you have been doing the first step in your journey to learning Cassandra. So, okay, there will be for this homework a bit of exercises, and you will see now what, plus 2 additional short courses, and they have this appearance. So these courses are, one is about data modeling, and the other is about the query language that you will soon see, the SQL that you've already encountered in Alex's slide. These courses are very cool because they contain a bit of theory, a bit of explanation, and then with this button, you start an interactive scenario. And in the browser, you will be able to interact with an actual Cassandra installation and do a bit of things in a guided manner. So they are very cool. They are absolutely hands-on learning, and I suggest you to go and see what they have to offer you. Okay, so back to the part that you do within AstraDB now. Let's go. So, okay, I will follow these instructions. First, we have to create. So you have to create your AstraDB instance, so your database. Now, let's say you have registered by now with this link, and you will have to create a database. Now, we give you here the name of your database to use, and also the name of a key space. You have seen what a key space is. It's basically a grouping of tables. We don't have tables yet, but we will create a database and a key space in it. And the names are here. Killer Video Cluster is the database name. Maybe I'm trying to make it a bit bigger, but I want to be able to show you the whole screen. So name of the database will be Killer Video Cluster, and the key space name will be Killer Video. Maybe, Alex, you might paste it into the chat just for convenience, but okay, so one thing that, so as we said, AstraDB is managed for you in the cloud. Where and from which provider? Any. As you see, you're free to choose whether you want to use a GCP, AWS, or Azure. Let's say I want to use AWS. I'm based in Europe, so I will choose Europe, Middle East, but you're free, obviously, to go wherever you prefer. Maybe you want to reduce your latency, whatever. I'll click Frankfurt, why not? So database name, key space name, region, and provider and region, and then I can hit Create Database. Now, once you click Create Database, a lot of things happen, but you don't have to worry about them. So the database is basically created and spun up as a Kubernetes set of objects in Kubernetes, and behind the scenes, your database starts to exist. Obviously, creating a whole Cassandra database takes some time. Indeed, as you see, this killer video cluster database is there waiting for me. Actually, it's still in the pending state. And it will be like that for, say, 2 minutes or so. Now, I would like you to give me a thumbs up when you achieve this step. So when you see your database, even in the pending state, so on, please give me a thumbs up so we can track that you managed to reach this point. So register into Astra, creating the database, name of the database, name of the key space, click Create Database, and you should end up here. Alex, do we see some thumbs up?
Give me a moment. You actually just asked for them and we have a few seconds delay.
Yes.
So not yet.
Okay, so we give you a couple of minutes. In the meantime, I'll show you a few cool things of AstraDB. Okay, so as I said, AstraDB gives you usage of a database for free, and that's up to quite a lot of usage. So you will still be in the free tier if you do something like 40 million reads, 5 million writes, and several tens of gigabytes of storage, if I'm not mistaken. So you will be able to run not only experiments, but also, well, actual applications, maybe small business, even without surpassing the boundaries of the free tier. So that's a pretty cool thing. By the way, every month you will have $25 of credit for you to use. Every month they will be renewed for you, just for your applications. But look, the killer video cluster that I just created has become active. So how are we, Alex, in thumbs? Did someone manage to get their database running?
Yeah, looks like we have already some
great.
people getting their database in running or at least pending state. And
okay, so we wait a little bit more and we move to the README in the repository. So let's say we created the key space, so the database and the key space. So everything is here in the instruction. So choose every provider, every region you want, create the database. You will see it in pending state, blah, blah, blah. This is something we said. So, okay, we have a database and a key space. As we saw before, a key space is a container that will contain generally tables. And as you can imagine, there are no tables yet. We have to create them. Now, there are several ways to create tables. There are, in general, several ways to interact with Cassandra and with AstraDB. You can do that with drivers. You can do that with different kind of interfaces. And on that, there will be a very interesting talk by Cedric Lamven later about something called Stargate. But now we are going to interact with the database with a console that will make us able to just type SQL commands. Now, a cool thing about Astra is that you will have access to a console in the browser to just work with your database. Now, I will assume that most of you have your database running and active state now. Alex, what do you think? I can go ahead?
I think so.
Okay, so I'm here, I'm seeing all of my database. I locate the killer video cluster that we just created, and let me click on connect. So I'm now in the part of the Astra UI about my one database. And as you see, there are very many ways to connect with it. Now, this will be explained, this will be seen in different parts of today, but there are various ways of interacting programmatically with it. So document API, GraphQL, various programming languages, a lot of different ways. And one of those, look here, there is a tab called CQL console. Now, let me click on it. Within the browser, if I go to the CQL console tab, I will have a nice console. So you see this black part here, it's a real console where I can type commands and click enter to execute them. By the way, if this weren't AstraDB, but if this were regular Cassandra, you would have in your own bash, in your own shell, you would have a way to connect with a very identical console. So these are really general commands that you are seeing. Now, let me go back to the README, because we have to create a table. So, okay, we went to the SQL console, and let's see what you can do. So this console works as any other text-based command line interface. So you type commands, and you hit enter. So let's see. Are there key spaces? Well, we created a database with one key space, so I want to see them. And I type desk, which stands for describe, desk, key spaces. Now, remember that every SQL command generally has to be closed with a semicolon, like here. I hope you're able to see. I'll try to make it a bit bigger, but... So if I type desk key spaces, enter, now I see all of my key spaces. Now, you see there is my good old killer video, the one we created. Very good. All other key spaces are just system things. We don't care now. We cannot care about them now. Okay, so there is my killer video here. Now, a cool thing of SQL console is that there is tab completion. So you not always have to type the whole command. Now, I want to tell my SQL console to work on the killer video key space, and I use this command to do that, use. Now, I would like to type use killer video, but probably if I hit tab, bam, I get the command. So now, enter, and I have. Now, my SQL console will work on the killer video key space. As you can see here from the prompt. Alex, do you see something in the chat? Can we assume that our attendees are more or less following along? Very good.
We are good, but there were just one incredible question I really liked a lot. Cheshire Joe asked, if I understand this correctly so far, by learning to use Astra, I don't need to learn specific of handling database with Google or Amazon Web Services. And that is exactly the point.
Yes.
So we take care of it for you.
Takes away all of the burden of managing and operations on your database. That's correct. Obviously, in general, so today is about Cassandra, and if you use a generic Cassandra, if you install Cassandra, whether on-premise or in the cloud by yourself, that's a different story. So in general, if you use Cassandra, vanilla Cassandra, so to speak, you will also have to deal with operations, managing, upgrade, everything. And there are some reasons to do that in some cases. But what AstraDB does actually is it takes away the burden of operations that sometimes are just something in the way between you and your working application. So yes, that's exactly correct. Okay, so we are in the SQL console and we are on the killer video key space. So describe key space, use killer video. We are just following the instructions to do some practice on the database. Now, let's create a table. So this is a cool command. Look, I am about to copy paste this command back in the SQL console, but look at this command. I think this is something you saw already in Alex's slides. So create table, okay, there is if not exist, just as a safety catch. Create table, users by city, and then there is a bunch of fields. So column name, column type, column name, column type. And then this very important part of the create table command that specify not only the primary key itself, this one, but also with this additional set of parentheses, well, it specified the partition key. So if you remember what you saw in the previous slides and what Alex told us, we are creating a table with so-and-so columns, and in particular, uniqueness is defined by those 4 columns, and partitions is defined by city. So every row, all rows with the same value of city will be one partition in the way data is grouped and distributed across the nodes. Now, let me copy this command to create a table and just paste it here, enter, done. We created a table. Now, how do you check that this table has been created? That's very simple. Describe tables, semicolon, and there we go. You see in the output, users by city. Sure enough, the table is there. Okay. Let's insert some data. Why not? So the table now exists, but it's empty. So there are ways to insert some data. But before doing that, let's create a few other tables, 2 more tables. So a table called comments by user and a table called comments by video. Now, you might see that these tables come from a larger sample application, actually called Killer Video, that is a very big and developed sample application showcasing a lot of features of Cassandra. And it's basically a YouTube kind of thing. The example was also somewhere along the slides that you saw, and it's an application managing videos and users commenting videos. So the various ways of handling relations between videos and comments, users dropping comments on a video, and so on. So we create 2 more tables. I want to stress the fact that in this case, user ID is not a text. So before that, you just had the text columns. All columns were text in the previous table. This time we have UUID, time UUID. So just, okay, let's not dwell too much on this, but just so you know that Cassandra has a rich set of data types, and you can have columns of type integer, time UUID, date, and so on. Okay, so let me just create those 2 tables that are both about comments on videos, but they are grouped differently. That's maybe something interesting. I just pasted the commands and hit enter. Now, as you can see, the tables look very similar to each other, but they have a different primary key and a different, well, the primary key is the same up to sorry, it's different. And in particular, partitioning is different. And as you will see in the data modeling workshop, this hints at the fact that those 2 tables are born out of 2 different needs of that single application, 2 different ways of querying the data, of getting the comments. Okay, so we created a few tables. Now, you now know what I want to do. I want to describe tables. So what are the tables in the Killer Video key space? There we go, 3 tables ready for us to play with. Okay, now we want to do some CRUD. So we want to create data, retrieve data, update, and delete data, just to see the usual way of interacting with a database based on tables. Okay, so look, we now can insert a few rows. Look at this statement here. Insert into table, and then there is a series of column names, values, and a matching series of values to use for those columns. So let me paste this command here. We are now inserting into the comments by user table a row with these and with so and so values for the various fields. Now, an interesting thing is that user ID is an ID, and we paste a literal for that, while comment ID, which is a time UUID, so a kind of a field type encoding both a unique identifier and a timestamp, It's actually a UUID 1, standard UUID 1. So for that, we don't give a literal value, but we just leave CQL to handle things for us and to generate an ID. So let me paste this command in the console here. I'm inserting into comments by user. There we go. I inserted my first row. Let's just do similar insertions in comments by user again. So you see always on the same table, I'm just inserting a bunch of rows. And there we go. We wrote a few rows. Okay, so now we insert another set of rows, this time in the comments by video table, just to have some fun. Okay, so let me just paste all of these here. No big deal, just so you know. Now, these are several comments on the same video. So 1, 2, 3, 4, 5, 6, 7. I'm inserting one comment, another one, always on the same video. Plus, at the end, I'm inserting a comment on a different video ID. So this is somehow a hint of a one-to-many relation between videos and comments, obviously. But okay, we just inserted a few rows. Now, we want to read those data, right? How do you do that? Well, that's very simple. In general, you would be able to just run a select query. So let's try. Select splat from comments by, here it says by user. So those of you who know SQL would probably find this statement very familiar, and the result, sure enough, are there. So you see, we are now finally reading data from the table. The very same data we inserted, of course. But surprise, surprise, this is not the right way to query a Cassandra table, because you now know everything about partitioning, and you know that this query in general would have to go asking all nodes to get all data, because I'm doing a select splat. And that's really against the philosophy of Cassandra. The right way of querying would always have to specify the partition key. So every query, even if I have a cluster of 1,000 nodes, the query goes to one single node, straight to the right node to get the data, because it goes to the node holding the data. So everything is very smooth, and the access time is constant, even as a function, even if the cluster is bigger and bigger, the access time stays constant, which is the power of Cassandra. So this is the right kind of query to run. So select from comment by user where user ID equals something, because user ID is the partition key. By the way, if you look at the SQL results, there is a color code reminding me that user ID is indeed the partition key. And that's very handy. So that's the right kind of query I would have to run. And you see, now I'm getting 3 rows. Now I had to make my characters a bit too big for you to better see, but you can see it's 3 rows because it's the 3 comments on the 111 video. While if I just run this questionable query with the star, sorry, with the full table scan, there was also a 4th comment on the 222 video. And that's the right way to query. So going straight to a single partition. Okay. This is all very well explained in this README. So you can go back to this and study it better if you want to get more insight. Okay, so we wrote data, we write the data. Let's okay, sorry, there is still some reading to do, just nothing new. Obviously, we are now selecting from comments by user, the whole thing. From comments by video, similar. So you would see again the whole table. These are all sort of questionable queries in a sense. Okay. Okay, so let's see what happens when you have to update an existing row. That's okay, so we insert a new row in the comments by video. Now we are inserting a comment on a given video, and the text of the comment is, that guy Patrick is such a geek. Okay, so let me insert this row, and let me check, select comment from comments by video, where video ID equal, sorry, I pasted the wrong thing, where video ID equal these. Okay, I have 3 of them, so I can maybe be more precise, and comment ID equal this thing. So just to change a bit. Okay, so you see now in the select, I can also select a specific column, obviously, as in SQL. So I'm now looking at the text of this one comment that I just inserted. Very well. Now, how do you update it? So, okay, so this is how we created the table, and you see that video ID and comment ID they form the primary key. Now, you can guess, if I want to go to a single row and update a value there, I have to specify the whole primary key in order to go to a single row and change its value. So at least video ID and comment ID have to be specified if I'm about to update a value in that one row. Indeed, this is how the update statement looks like. Update table, set column equal new value. You see it was on such a geek, and it's becoming is on fleek. So where video ID equals something and comment ID equals something. Let's run this update statement. But before doing that, let me clear my screen. So at the moment, this comment contained this text here. Let me paste the update, and let me run again the select. Aha, you see, I successfully executed my update. The same select as before now gives me the new value. And that's it for the update. Let's just check if I'm able to delete data as well. So that's very similar, because if I want to delete a row at that one single row, I obviously have to specify the whole value for the primary key, because I have to identify that one row. Indeed, the statement looks like delete from table where, and there are where conditions. And if you look, now that's too big to be clearly seen, but in the where condition, again, I'm specifying video ID and comment ID. So the whole primary key. And this is my delete statement. Let me run it. And why not? I can run again my select. You see? Guess what? 0 rows. Now, just a side remark. The update and the delete share much more than it looks. Actually, a delete is very similar to an update in the sense that deletions in Cassandra work by inserting special values, special things in the table called tombstones that mark the fact that that row, that value has been deleted. So actually, no surprise that they look very similar, and in both cases, you have to specify the primary key to work on a single row. Okay, so as you see, the row has disappeared after deletion, and we got to the end of this small exercise. Now, let me remind you, you are encouraged to run through these instructions by yourself to better understand them, to play a bit with them. Maybe you can invent your variations, you can play a bit. And in particular, if you want to please do the homework. Take a screenshot of the results of this select before and after deletion of the row to show that a row is actually disappeared. And then please go to these scenarios here, because they are very cool and they guide you in a hands-on way, and they make you learn a bit more about Cassandra and how it works and how you operate it. Okay, that being said, I can give it back to you, Alex.
Yeah. Thank you so much for the great job. I will grab the screen back in a second. So, doesn't matter if you followed the lab right now with Stefano. You can do it also later, and we do suggest you to do it because, well, practice is golden, and just the raw knowledge won't really stick to your brain well enough. It always works better than you practice. And then you do it, submit your homework as Stefano explained it, and we will issue a participation certificate or badge, upgrade complete achievement to you. Now, if you want to practice more, there are katacoda.com/datastax/courses Cassandra intro, and in general, plenty of great courses at katacoda.com at DataStax. With very many interesting things, and you don't have to install anything. It's all available in the cloud. So it can be a very good chance for you to improve your knowledge. And main place for us to meet afterwards is academy.datastax.com, because there you can pass the real full course to become a Cassandra certified developer or administrator. Don't forget to grab your voucher. It's a limited offer, so you don't want to miss it. Stefano, may I ask you to copy-paste the link to the voucher again in the chat, please?
Absolutely.
Yeah, we have a lot of great questions today, and we have a lot of great attendees today. So by no circumstances, I want you to miss your chance to get your voucher later.
So, sorry, I'm pasting the voucher form, but please, since the results of feedback where we ask you what is the workshop you liked most, maybe you might want to wait until you see all of them.
Yes, please.
Anyway, before answering, because there is still much more to come in both rooms. So yeah,
right.
Here's it. It's open already, by the way.
So I believe we are right on time.
Yes.
Thank you so much for attending it. And what's our next plan? Our next plan.
Sorry.
Yeah,
go ahead. No. Okay, so now we have a break because we are at the end of the workshop Core Cassandra. We have a break in AEDT time. It's 1:45. We have a break until 2:30. So 45 minutes of break, and then we reconvene for the quiz.
Right.
Let me drop it in the chat.
Then I believe we are done for now. Stay tuned. Jump in after the break. Take your chance to win the prizes. And see you then in 45 minutes, right?
Right.
Perfect. Okay, then. Thank you so much for coming in. You have a great questions. It's nice to see how professional our community today. And have a great time. See you soon.
See you later. Bye.
Hey, looks like we are back online. Welcome, John Lee. And you know me already, but John, could you please introduce yourself?
Hi, everyone. Good to have you here. I'm only about 2.5 months new to the DataStax family, and I'm very happy to join this community. So thank you very much. I'm based out of Australia, and look forward to have a chance to interact with you both now and in the future. Thank you.
Where exactly in Australia are you located, by the way?
I'm
Just
based out of
curious.
Sydney. I'm based out of Sydney. That's
Okay.
why.
So, looks like you have at least one neighbor of ours, Jeremy Hanna. I believe he is moving to Sydney or something like that. I'm not so good in Australian geography, sorry guys. I promise to become better and then. So, whatever, we have to start with the questions, and that's how it works. First, you go to menti.com. Mostly, we recommend you to go with your phone. It's the easiest way to participate. And use the code 61339063 as it's stated by Stefano already in the chat. Or I will give you something better. Maybe you can just scan this QR code next to John, and or pick the code next to me, 61339063, and please join. I believe we have you have a very high chance today to win some prizes from DataStax. So let's see how it goes. Meanwhile, we will start with the simple questions. It's not the quiz yet, but just to make you familiar with the Menti, so you will know how to push the button. And first question is, what's your experience with relational database management systems? What do you use? Doesn't matter. MySQL, Postgre, Oracle doesn't matter for us at this moment, because the idea of SQL is the same for all of them. And we want to know what's your experience with them to understand you better. Okay. Looks like we have people with some experience already, which is great. Or even a little experience also sound good to us. If you not so much experienced than that, that's not a big deal for us. But of course, it will be easier for you to get data modeling better. Good. But at least all of you have some experience. That's already great. Meanwhile, don't wait. Jump in, because quiz starts very soon. Now, what's your experience with NoSQL databases? Okay. Now distribution is a little bit different. So we have people with some NoSQL experience. Okay, some complete newcomer in NoSQL world.
There's no guru in the room.
Yeah, but of course distribution is a bit different. People use it to have more experience with relational databases than with non-relational. What's your experience with Apache Cassandra or DataStax Enterprise, Astra? Okay. Someone has answered known, but you know what? If you attended the Cassandra Fundamentals workshop, you already have general understanding. I believe I did my work well. So, and Eric Ramirez and Stefano Latini answering questions in chat also. So I believe you already have general understanding. But we don't have too much Apache Cassandra experts today, which is also very fine. Okay, thank you. So that's the last, yeah. Let's rock, let's roll, and that is a last call for you to join the game and pursue your chance to win the prizes. So last 10 seconds. And
this is getting well. Hey,
yeah, okay. Give me one more and we will start. I see we have a lot of attendees. That is good, but we can have more. So 10 more seconds, 10 more seconds. Okay. Will I have one more? Okay, time is over. If you miss the first question, you will have lesser chance to win. Now the competition begins. Now, oh yeah, finally. Now we will have questions and it's important to answer fast. Now, so you get more points. If you watch us on YouTube, and mostly probably you do, YouTube has some solid delay. So, easiest way for you to have higher chances, read questions on your mobile phone. They will appear a little bit faster than on YouTube, okay? So you will have more chances to win. Ladies and gentlemen, we start. And let's go. Answer fast to get more points. How many master nodes does Cassandra need? At least 3 per cluster, 3 per data center, not a single one, enough to maintain consistency. How do you think? Yeah. How do you think? How many master nodes does Cassandra need? Okay, now I'm very curious. Okay. Some of you paid attention to what we said, but some of you did not really well. Take a look. So, John, how many master nodes does Cassandra need?
well, like what is on the screen, not a single one. It's all peer-to-peer, right?
Right, Cassandra is decentralized, peer-to-peer. That is not like free per cluster or free per DC. The concept of master node does not exist in Cassandra. There is no thing like a master node, and Cassandra is decentralized. So now let me see the winners and who gave the fastest answer. Looks like it was George with 971 points. Great job, George, and Homer following him pretty close. Well then, let's take a look on what's going on then on the next question. And that's question number 2. So, answer fast to get more points. Executing select query without the partition key is the recommended way to retrieve the data, the right way if the data was inserted without the partition key, a way to full cluster scan, illegal and punishable by law. We have some interesting options here.
I'll pick illegal and punishable by law.
I'm absolutely with you on that. So, right answer, select query without partition key is a way to full cluster scan, and it is bad and you do not want to have it, and we do believe what it must be illegal and punishable by law, but not yet. We will, you know what, we have to work with our legal department to make it happen maybe.
Yeah,
So,
and Alex is the enforcer. He'll come to you.
right. So it's not the recommended way to retrieve data, quite opposite. It's the not recommended way. And it's not the right way if the data was inserted without a partition key, because you always must specify partition key when you insert data. It just, you cannot store data without a partition key. So how did you make it? Okay, Homer makes a mistake. And George made it right. So now we have the list of the winners: George, Such, and Jasper Fan. And Alok was fastest, but he made a mistake before.
Oh, very close.
Yeah. Question number 3. Answer fast to get more points. How data is being distributed in Cassandra cluster? By partitions. All data is replicated to each server with address locators or using postmail. Yeah. Everyone has voted, and looks like it was easy for you. Yes, by partitions. And what do you think, John, about all data is being replicated to each server?
Yeah, I think it's close. It's a close answer, but yeah.
No, data is not being replicated to each server because on a big scale, like Apple scale or Netflix scale, it will lead just to it will just simply not work because there is not a single server what can fit such size. So there is no need to replicate data to each server, but the data is distributed by partitions. Okay, so how was it? Alok makes mistake. Alok and Asif Karim, that was a mistake. But Dragonite was fastest. Good job. And George, Such, and Jasper Fan are still holding the first places.
Yeah. Well, Rec make a really good recovery.
Yes, good recovery. Right.
Number 4. Well done.
Let's go. Answer fast to get more points. How to scale Cassandra cluster? Vertically, upgrading servers, increasing scaling factor. Horizontally, adding more servers. Don't scale. Cassandra performance is always enough. That would be a nice option.
Well, I think if you use DataStax extra, then you don't have to care about scaling, right?
Right. By the way, that's a nice point. Astro is serverless, so it will take care of the scaling for you. But working with Apache Cassandra, self-hosted, you scale horizontally, adding more servers. And that's the right answer. And there is no thing like scaling factor, there is replication factor, but it won't help you to scale out. And vertically, upgrading servers is the approach more traditional for relational databases, but definitely not for Cassandra. Okay, so who was the fastest? And who was the fastest? Hey, George was the fastest. Great job. So, Homer.
George must be using a really fast phone.
Yeah, looks like. I see Homer make a good job getting very close to top 3. Maybe some of them will make the mistake. He will catch up. So let's take a look on what's going on.
Hey, Rec, ready? I'm rooting for you. Come on.
So, which replication factor is recommended? 1.5, 3, 15, 42. There are some options, but which replication factor is recommended? Everyone has voted. Oh, that was simple. Take a look. No one even answered 1.5. It's still my favorite option so far, but I not really understand how it could work. Like half bit or half server? Not sure. But the right answer is 3 indeed.
Well done, everyone. Now, who is the fastest here?
Yeah. So, who is the fastest this time? George again. That's a good job. Okay, it was easy. Let's take a look. Question 6. Answer fast to get more points. Cassandra cluster can be deployed on AWS only, any combination of cloud providers and on-premises data centers, only one cloud provider of your choice, Sega Mega Drive in case you need it.
I think it's a competition of who is the fastest. The answer is very clear.
Right, any combination of cloud providers and on-premises. We have really focused audience today because normally there are mistakes on this question, but you did it all great. Well job, everyone. But who was the fastest? Okay, so Jasper Fan was the fastest, getting to the second place, overtaking Such. Good. Okay. So, next question. Question number 7. Answer fast to get more points. Cassandra cluster can have multiple data centers. Wrong. Single cluster can have only one data center. Correct. But not more than 2 data centers. Correct. Some data centers are passive. Correct. All data centers are available for read and write. Okay. And time is up. Correct. All data centers are available for read and write. First option is wrong. Single cluster can have many data centers. Second option. Sorry?
No, I wanted to say that's why Cassandra is so powerful in speed and performance.
Yes, yes.
That remember.
Cluster can have more than 2 data centers. And all data centers are always active, so you can write to any of them. So the right answer, correct, all DCs are available for read and write, and most of you made the good job. So, who made a mistake? Oh, Such is making mistake, and that means what? Homer will take his chance, and okay, at least getting closer, not yet. And Alok is returning to the 6th place. That is a good job. Danny was the fastest one, but he is only starting to grow on the leaderboard, and we are in the second part of this quiz. Question number 8. Keep going and answer fast. CAP theorem claims what in case of failure, C, A, and B are all guaranteed. Only A is guaranteed. Only 2 of 3 capabilities are guaranteed. We will need a new cap. So, all right. Such an audience today. That's incredible. Right. Nothing to explain. You all got the idea. Okay, but who was the fastest? Okay, George is leading, still leading. But I have to say, what just for fun is just like 300 points difference to George. It's not too much.
Yeah.
Question number 9. Answer fast to get more points. Recommended way to reach immediate consistency is read write 1-1, read write 1-all, read write quorum with a video chat. I don't know, when I need to reach consistency with my colleagues, I always use a video chat. Maybe it's a recommended way for Cassandra too. For me it works. Okay, no one picked video chat. So the right answer is quorum. Read write 1-1 won't lead you to immediate consistency at all. Moreover, with some big chances, it can lead you to not inconsistency. So that's wrong. And read write 1-all, though technically does lead you to immediate consistency. 1 plus 3, 4 higher than 3, mathematics works. Read write 1-all will give you immediate consistency, but it's not the recommended way. That's why this answer is wrong. Read write quorum is the recommended answer. So
maybe Alex, maybe they can video chat you next time, right? When they want to.
Yes, I will happy to have more friends on Slack.
Yeah.
Take a look, he did it. Homer made it to the top 3.
Hey.
Great job, man. And Danny Rishke is the fastest again. Keep his climbing on the leaderboard. That is a great job. So
it's so exciting. It's like watching a horse race.
yes. It's really exciting. I love quiz. Is my favorite part of the Cassandra Day.
It's currently spring in springtime in Australia. So there's a lot of horse racing on. So this has the same feeling.
I have to admit, I never have been on any kind of horse races. So maybe I will attend one when I will visit Australia. hopefully.
Springtime. Springtime.
Let's go. So springtime, I will remember. Then question number 10. So answer fast to get more points. What is a key space? What is a key space? It's organized into rows and columns. It contains tables and defines replication. It's defined with partition key and contains rows. It's the place to store keys. How it goes? And who will make the right answer? Okay, most of you made it. It's organized into rows and columns. No, it's a table what's organized into rows and columns. And it's defined with a partition key and contains rows. No, it's a partition. So right answer, it contains tables and defines replication and some other settings what we don't cover today. So, oh, that is getting interesting. Just for fun makes a mistake. So Homer gets to the second place and Rakhavendra Reddy gets to the third place, overtaking just for fun, but not for too many points. Meanwhile, George looks like the only guy who did no mistakes as far as I remember. And we are getting to the next question. And notice Danny is fastest again, so now he is on the 7th place already. Despite missing the beginning of the quiz, he is climbing higher and higher. That is interesting. Question 11. Answer fast to get more points. What is required in the Cassandra table? Data columns, clustering columns, partition keys. Nothing is required. Everything is allowed. Okay. So, what is required in Cassandra tables? Partition keys, it was easy. Right, partition keys. Data columns are optional. Partition keys are required. So, who was the fastest this time? Oh, Homer, I cannot believe. Come on. Unbelievable. He falls down from the top 3. George is fastest again, and Rakhavendra got to the second place with just for fun, returned to the top 3. Only top 3 places are getting prizes. So, question number 12.
Stays there. Jasper, Homer. Come on.
Battle goes on. So, answer fast to get more points. Cassandra tables contain multiple partitions, only rows and columns, replication factors, endless seas of dreams and fears.
I can relate to that, Alex.
Yeah, I can understand. That is good. Okay, now take a look. That was very important question because I want again highlight a thing. Take a look. If you underestimate the importance of the partitions, if you don't care about the partitions enough, 2 bad things will happen. First of all, you will have a bad data model because of that. And because of the bad data model, second thing will happen. Cassandra's greatest performance, scalability, and so on is a shared responsibility. If you don't do your work, Cassandra cannot do its own work, so it won't work as it can. And don't blame Cassandra. Cassandra does its part, her part, very well, believe me. So remember, Cassandra tables contain partitions, and partitions contains rows. And if you forget about that, you will have problems. Not with me, well, with me too, but first of all, with your production cluster. So, how it goes here? Oh my God.
Oh,
Okay, that was unexpected. And Homer gets to the second place.
Yeah.
And George is doing amazing job. Looks like we know the winner already. But second and third place, there is a very minor difference between Such and Rakhavendra, and just for fun, it's still close. And Danny, by the way, Danny got to the sixth place out of blue. Out of a blue, that's a great job. That is a competitive soul. I like it. Let's go, and we are getting close to the end, and that's question 13.
Couple more questions.
Answer fast to get more points. How Cassandra executes joins? Joins in Cassandra require dedicated joint table. Just like in SQL, it doesn't. It does, but kinda lazy. So, how Cassandra executes joins? And time is up. So, answer is simple. Cassandra does not execute joins. Cassandra is a NoSQL database. There are no foreign keys and no joins in Cassandra. Why? Stefano will explain you in the second workshop, so stay tuned and let's go. Okay. I can't believe the competition is so interesting today. There are and take a look, Danny made it to the fourth place already.
Yeah,
using mistake of others.
By being the fastest.
Yeah, fastest, and that is a killing spree of the right answers fast enough, and that's the fourth place.
Watch out, Rag and Sue. Watch out for Danny and Homer. They still have a good chance to get into top 3.
Yes. So Such must be worrying today, and Rakhavendra is also, I guess, only George can just skip this question and still he secured his first place already. Even if he will get no points, he already have won. That is interesting.
I'm sure George still want to compete for the fastest, so let's not discourage.
Right. Fastest title is a big honor, I would say. So, ladies and gentlemen, you know what's going on to happen right now? That's last question of our quiz. So, breathe out, breathe in, warm up and stretch your fingers and get ready because we go for the last question. Quite complex question. So please now
put on your game face.
You know what to do. Answer fast to get more points. Single data center cluster of 8 servers. How many servers we have to add to double the performance? 4, 8, 12. It's not possible to double the performance in a single DC. How many servers you have to add to double the performance in this scenario, considering our data model done right? Disclaimer. Yes, that was a competition.
You gave the hint in the previous questions, right?
Right, of course.
Yeah.
Of course. So let's take a look. Right answer. With the data model done right, to double the performance, you have to double the count of servers. Easy is that. Let's call it linear scaling, and it's a great feature. It's just incredible feature. What is available only on a very limited amount of databases, and Cassandra is definitely one of them. So, answer 12. 12, of course, will help you to double the performance, but it's definitely overkill. It's not possible to double the performance in a single DC. No, it's possible. And finally, 3 people answered 4. You know what? There are some laws of physics, and if you live in the place when you can double performance by half of the servers, let me know where do you live, because I want to move to your place. That just sounds magical. But in the real life, with no unicorns and dragons, it's not possible in this case. So right answer is second. And we proceed to the leaderboard. You know what, John, I am really nervous at this point.
Me too.
Oh. That is something. And he made it!
Done.
You know what?
Cool.
I do congratulate George. It was incredible job. It was just really
Awesome.
incredible job. Such also very close. Couple of mistakes, but overall very good performance. But Danny, it was really well done. Like smoothly question, but question missed a couple of questions in the beginning. That was smooth.
I think George need to go back to your pre-question and answer the survey as a guru in Cassandra.
Yeah.
I think he deserved that.
Yes, sure, absolutely. Now, I congratulate the winners. Winners, George, Such, Danny, please make a screenshot of your phone or whatever you use and send it to jack.fryer@datastax.com. It's on YouTube chat, thanks Stefano, to claim your prize. Now, if you are not in top 3, but still of the leaderboard, I do congratulate you because even to be on leaderboard in our competition, it's already a big honor. And finally, for everyone, you know what? Our prizes are nice, but let's say we don't send out Ferraris or villas in Italy. Sorry, maybe we should, but next Cassandra Day, maybe. But what really matters is your knowledge. And with your knowledge you get today and still getting on the other workshops, you can be a better engineer, better developer, have better salary, better job title, and so on and so forth. So you can be a better expert, and that's what matters in the end. So I congratulate you with the participation. It was a very smart move to join us. Now, what's going on next? We will have next workshop in this room. I do recommend you to attend. We will have Stefano Latini speaking about data model done right. And that's essential. Data model, right, is the essence, is the key to be successful with Cassandra. It's the most important workshop of the day. And in the second room, we will have some more talks now starting. Let me check the schedule. Next will be Cassandra with Jonet Singh. Jonet Singh will show and tell how do you run Apache Cassandra on Kubernetes with Cassandra, our special open source project, which is very interesting if you are into infrastructure and Kubernetes, so much recommended. Then make your decision, stay here for data modeling workshop, we start in a couple of minutes, or switch to a next room for Cassandra. Thank you so much for joining. John, thank you so much for being with us today.
Thank you. Yeah, I do want to tell all the participants here, go spread the word. Take what you learned today on Cassandra and spread the word. We need to increase our community. We need to increase the number of users that's using Cassandra. And hopefully the next time I run this, because of you spreading the word, we can get bigger sponsorship and give out better prices, right?
Right. And moreover, we will have Cassandra Day Australia next year, and maybe you will be already certified Cassandra developers, and maybe you can be our speakers. We accept call for papers, so go make some fun with Cassandra and submit for call for papers next year, and we will be happy to accept it.
Fantastic.
Okay, so now we are going for a moment to hold on, and we will get back to you in a moment. So please stay tuned. I have to switch to the next. I'm sorry. Okay. See you soon.
Bye.
everyone. And welcome back. That's
And here we
data
are
modeling.
back.
Right. Building
Okay.
efficient applications with Stefano. And I will be mostly answering questions in the chat, but I will be happy to do so.
Great. So, I've seen the quiz, how it went. Congratulations. It's been a tough challenge for those of you. Congratulations to the winner. I hope it's been fun and entertaining. Now it's time to get serious again. And let's talk about data modeling. Yeah, so data modeling. In other words, how not to shoot yourself in the foot with Apache Cassandra. Okay, so before we start, let me just remind you of a few things that have been said already this morning. This whole day will be recorded and available on YouTube, so you can go and watch it again and everything anytime you want. For the questions, you know that you can ask them in the chat, where Alex and I will be keeping an eye, and maybe somebody else as well. But maybe it's even better if you put your questions in the Q&A site, so we can discuss them in a couple of hours from now. Or you can, and you are encouraged to reach us and join us on our Discord channel, the Fellowship of the Cassandra Ring, where we can discuss and answer your question and help you and whatever without end. So as opposed to the YouTube chat, the Discord friendship will stay. Okay, so we are going to, there are a few other links that give you various ways to get information on Cassandra and connect with us. So please consider that. And maybe you can also want to follow us on YouTube. Okay, so get ready for 2 hours about data modeling. Now, another little point is that we are going to review some of the things that you've seen already this morning, but a bit of familiarity with the Cassandra might help today. And in a sense, also some familiarity with relational database might help. But it might also be an obstacle, and you will see what I mean by that. Another point is that today I will speak about Cassandra. By Cassandra, I will mean in a very broad sense, either Apache Cassandra or DataStax Enterprise, which is a commercial fork of it, or even the AstraDB, which is built on Apache Cassandra. And this is the product that you've been using this morning for the little exercise we did together, because they share the same interface, and the same underlying architecture, as far as we are concerned, at least. Okay. So who am I? We met this morning already. I'm Stefano. I'm a developer advocate at DataStax. These are my contacts, and you are encouraged to reach me and to keep in contact with me. So let's start. And what we will see today. First, we will have a bit of introduction on Cassandra, which partially overlaps with what Alex has already told you, but we will, repeating some basic points about Cassandra might help for what comes next. And what comes next? Well, we will start our journey to data modeling technique in Cassandra. And we will start by looking at what is denormalization. Then we will have a closer look at how data is structured and organized and stored in Cassandra, which is important to understand what are the right ways and the allowed ways to query data. With that knowledge, we will finally look at data modeling process proper, which is a very Cassandra thing. So data modeling in Cassandra, you will see, is a very specific thing and pretty upside down compared to many other databases. Okay, that would be the most important part of this workshop. And after that, we will complete your tool belt with a few other features and a few other opportunities to structure your data and your data access patterns in Cassandra. Okay, so let's start with an introduction. Alex, are we all right in the chat?
Yes,
Can I
all
go
good,
ahead?
all good.
Very
yes,
good.
Sure.
Okay, So let me remind you that you can leave your questions in the chat or even better in the Q&A website. So after this workshop, we will have the Ask Me Anything session and we will have more time to devote to your questions. Okay, so what is data modeling? Because, you know, this morning you've been playing a bit with a database. No, we've been inserting data after creating a table, reading data, changing data, and deleting data. Very nice. But probably your real business application will have to do something more. It will have to have a database structured in the right way to make your application, your complex application, work. Indeed, data modeling is the process of building the structure of your database so that your application works as good as possible. Data modeling starts by investigating what is your application, and it will lead to the point where you can actually create the tables. So create the physical structure of your database. Okay, so before looking at data model in itself, let's remind us what Cassandra is. Cassandra, Apache Cassandra, is a high-performance database, and it is a NoSQL database. It is fairly powerful in various ways, but as many times, power comes with the need to control it. So you need to know how it works and how to use it to harness and to express this power. Okay, so when we say high performance, we mean size. Cassandra is able to deal with very large quantities of data, the so-called big data at the web scale. Cassandra is able to cope with hundreds of petabytes database, which is a lot. It is really a lot of data. Think about that. And what is cool is that this database can work on commodity hardware, so you don't have to buy very expensive supercomputers. High performance means also speed, in particular, but not only that, writing speed. So Cassandra is optimized to be very fast also in writing, which is usually a pain point for many other databases. Indeed, Cassandra is able to support tens of thousands of operations per second per node. When I say per node, I mean per machine, because Cassandra is born to be distributed, very distributed. So one database can be spread across hundreds, thousands, even more nodes, which means machines, virtual machines, whatever. And the database is built from the ground up to be able to work in this kind of very distributed environment. And also that can be geographically spread all over the world. Okay, so what do we mean by NoSQL database? This morning we had a small remark about NoSQL being something like invertebrates. So it's more like a definition of what something is not. So NoSQL means that it goes beyond the usual relational transactional database paradigm. And there are many ways to go to be NoSQL, not necessarily much related to one another, but Cassandra takes a particular approach to that. We will see it. A big point is that there are no joins, there are no foreign keys, there are no transactions, and those are all compromises that Cassandra chooses in order to offer you its astonishing performance. But the consequence of this is that the way you model your data is radically different from a relational database approach. You will see it. Okay, so Cassandra is powerful, but you have to learn how to express this power, because it's, in a sense, it's easy to get the data model wrong. And it's particularly easy if you make the mistake of thinking, as Alex said this morning, of thinking of Cassandra as a relational database without join, tables without joins, and that's it, because it's much more, there's much more to it to have a successful data model. And this requires a bit of knowledge of the internals, at least how the data is handled and stored and grouped and distributed in Cassandra. Okay, another important point for about Cassandra is the distinction between OLTP and OLAP. Now, it's not a distinction, it's more like a continuous spectrum. There is, if you want, you can place your databases on an axis. The axis between OLTP on one side and OLAP on the other side. OLTP stands for online transaction processing, and it is the kind of workload of databases where, so it is the kind of workload where your application needs to access very often a lot of rows one by one in very simple ways. So you go to one row, you change a value, and that's it. You go to one row, you write a value, or you read a value, and that's it, usually. Those are simple operations, but there are usually a lot of them, and they have to be almost real time. So there might be something right behind my application, right behind the table that stores information about the number of, I don't know, the number of items in your store, something like that. So they have to be almost real time, fast, reliable. And usually it's always the same kind of queries. Write this, read that, and they don't change so much. This is OLTP. On the other end of the spectrum, you have OLAP. OLAP, which is online analytical processing, is the kind of workload where you have very complex queries, very complex ways of squeezing and treating and changing and analyzing and connecting your data. And that might be something like the very complex analytics that runs every week to squeeze insights which make you optimize your online store the day after. So very complex recommendation, associations, analysis of various kinds. And they usually involve a lot of joins. They are heavy. They need to coordinate and to compare data from various places in your database. And these are fairly complex and long-running queries. Luckily, usually they are not facing directly the client, the customer. They are more something like an internal kind of thing. My analytics department works for me, and they provide me with a report, a weekly report that then I use to better structure my offers, my special offers, for example. Such queries usually are a never-ending prototype. So they are changed, tweaked all the time, and nobody requires them to be real-time. So you see, those are two very different kind of things, and there is everything in the middle. So it's not a discrete kind of thing. Now, relational databases, in a sense, sit somehow in the middle of that, and they are more or less good at everything within some scale constraints. Now, Cassandra is focused on the OLTP side. So Cassandra is very good and very fast at supporting a lot of simple queries, simple reads, simple writes. That's not to say that this is the only thing that you can do with Cassandra, because there are layers and plugins that you can use on top of Cassandra as the storage engine, but Cassandra in itself shines on the OLTP side. That's one very important point. Now, Alex, you wanted to say something?
Yes, but a very simple thing. I believe we, as always, have a lot of attendees with experience of small to medium-sized projects, and that may sound a little bit not clear for them, as it was unclear for me like so many years ago, because we used to use these multi-purpose databases, and we use it to the situation what our database can answer all the queries we want to have. In the projects of a bigger size, that's already very often case when you have multiple types of different databases, purpose-built databases for different scenarios. That's especially now great approach with the growth of microservices or service-oriented architectures. And now we more and more often think of not a single database per project, but multiple databases per project working in the collaboration. When you have Cassandra as a customer-facing database because your customers don't want to wait. And then you have something, a site working, collaborating with Cassandra, maybe Solar, maybe Elasticsearch, maybe Apache Spark, which like building a team. Teamwork is perfect work. And then together it may answer all kind of queries, and that's much more often case, of course, for medium to big size projects.
Yeah, absolutely. So specialization increases over time as technologies get more and more refined, and the best result comes from using the best of every word, so to speak. So yes, I agree completely. Okay, so Cassandra, this is a slide similar to one you saw this morning, so I'll go very quick on that. Cassandra is able to deal with very big data. It can be configured to be very highly available because it doesn't have a single point of failure. It is you can configure it to be able to sustain a loss of entire data centers if you want. It can be geographically distributed, or generally speaking distributed, which means everything you saw this morning of the CAP theorem. So you have to pick your choices between C, A, and P. It is optimized for reading and writing, thanks to its very clever internal architecture. And what's also very important, it is vendor independent. So it is open source, protected by the Apache license. On the other hand, there are some cons, in a sense, of Cassandra. So it might require qualified engineers. That's true, because it's not very, let's say sometimes it's not very easy to manage. But that can be you. And speaking of that, let me remind you that on the job market, being a Cassandra specialist usually means having access to higher pays and better jobs, because there is much need now on the job market for Cassandra specialists. And guess what? We offer for free to you today. We offer a free voucher to try and go and take the exam for being Cassandra certified. And also, as for studying, the academy we give is for free, so please go ahead. There will be some more information on that later today. Another point is that Cassandra has a reputation of being hard to manage. That's sometimes true, so it has its own complexities, yes, but if that scares you, there are managed solutions. So you saw one this morning, right? AstroDB. Okay, so another point, as Alex remarked, is that Cassandra is OLTP specific. That's true, but it is very easy to integrate Cassandra with analytic solutions such as Apache Spark, for example. Another observation is that Cassandra has limited search capabilities, especially when it comes to the fancy searches such as NLP kind of indexing and similar stuff. But again, in the spirit of a collaboration between technologies, it's very easy to plug search engines such as those Lucene-based, Solar, or Elasticsearch on top of Cassandra. So those cons are actually not much of a problem. They just need to be approached the right way. Okay. So let me give you a teaser before jumping to the next section. Let's go back to data modeling. So the way you do data modeling in Cassandra is very different from what you would do in a relational database. And this table is a brief summary of that. So relational databases work with joins and indexes between tables. In Cassandra, you use the concept of denormalization that you will see soon. Relational databases are based on the idea of referential integrity. Cassandra doesn't. So Cassandra says goodbye to referential integrity, which, however, would not scale well when it comes to very big data and very distributed systems. So that's a forced choice, so to speak. In a relational database, the primary key is used to guarantee uniqueness of rows, while in Cassandra it is much more, because it is also related to how data is partitioned and you will see it is also related to how you can access data, you can query data. When you model your data to have your application work in a relational database, you start with the entities, while in Cassandra, you start with the queries. So the query will determine the tables. This concept will come more and more later. Which, in other words, means that when you model your data in a relational database, you start with the data and you end up with the application. While in Cassandra, it's the other way around. You start by looking at your application and you end up building your data structures. So this is a very short account, and the rest of today will be basically devoted to expanding on this one table. Okay. So, Alex, can I go ahead?
Yes, please. We are good.
Oh, great. Okay, thanks. Okay, so denormalization. Now, let's start with normalization. Normalization is an old and venerable idea that is more than 50 years old, and it is somehow the idea that is the pillar of relational databases. The idea of normalization is to enforce data integrity by having some formal requirements on table that, in a sense, boil down to one concept. You will not duplicate information. So let's say there are tables to relate recipes and ingredients, such as pizza, which is made by mozzarella and champignons. Well, the point is that you will not write pizza more than once. You will not write mozzarella more than once in your database. You see, there is one pizza, one mozzarella, and the relation between them is created by means of a third table that is just a table containing relations. Okay, so that's all nice and good, and it's formally, mathematically, if you want, it's a very good idea, very elegant. But on the practical side, as you start going to more complex situations than this three-table example, you will start to have slow joins. So when you have to get your data in the form your application needs, you will start to have very complex joins, very complex data queries, which means very slow. So your application will start to be a bit slow. And so this is just another way of looking at the same three tables. This is how you would create and populate tables of ingredients, recipes, and recipe ingredient in a SQL, in a relational database. And yeah, there is a good thing in this schema. So you first look at the word, you describe entities in the word with as many tables as there are entity types. Then you create other tables for the relations, and then whatever kind of information you need, you can just write the right query. You can have many queries on these tables, and that's it. So that's handy on one side. But still, even just to know what are the ingredients of a pizza requires, you see, this select with which has two joins. So it's really not very, it's a bit unwieldy, you know, to have to write such a thing. Think about a real life application that would probably soon explode to a lot of joins, a very complex query, and it's a bit of a mess on the long run. Okay, so this is the situation that started to appear. So engineers in the relational databases, as the amount of data started to increase, the problem was that if the database is relational, but the amount of data increases, at some point the queries are just too slow. If you want to comply with data integrity and to have a lot of joins in your queries, it just starts to be too slow. So one thing is slow, one thing is slowness of these queries. The other is that maybe one single computer, one single machine started to be too small for the big data. But in particular, speaking of the speed, even in the relational world, engineers started to compromise the ideal formal idea of normalization and started to, you know, break the rules a bit. So for the sake of having faster queries, I duplicate the data here and there secretly, a bit of a clandestine thing, just in order to have faster queries. Because usually it is reads that have to be very fast, because usually it's mostly reads behind my application. And if reads are fast, and if I prepare denormalized data in my tables and reads are fast, then my customers will not abandon my website to go to the competitor. So there was a very compelling reason to start doing this. Now, you get the point. This idea that was a bit of a secret, a dirty secret in the relational world, started to be sort of the only way to have acceptable performance. And look at this table. I have a horribly non-normal form table where pizza appears more than once. Pizza mozzarella, pizza champignons, these are just 2 rows. But if I want to know the ingredients for a pizza here, it's a simple query, and it's probably going to be very fast. Now, what Cassandra does is, let's take this idea and make it the pillar, the tenet of how you model data in Cassandra. So let's say goodbye to normal forms and just accept denormalization as the right way to high performance and to big data. Indeed, that's basically the principle that underlies the way Cassandra wants you to structure data. So you can formulate this idea also in another way, namely, let's have redundant data. No problem with that. I can duplicate my information. I can duplicate every piece of data as much as I need in order to achieve a very important goal. Every query has to go to a single table. No query shall look at more than one table. So you see this sketch at the bottom of the slide. On the left, you have the relational case. Every query has to look at various tables and do some stuff. Look at the right case. In Cassandra, every query has its own table. At least every query goes to one single table. Easy, linear, no joins. Indeed, Cassandra has no joins. There are no joins. There was also a question in the quiz. There are no joins in Cassandra. So you sort of have to prepare your data for those queries to be the queries you need. So there are no other ways to get your data. This is for sure a faster way of accessing your data. There is also a detail that if you pre-cook your data and sort of perform the join at write time, so you collate your data, duplicate, and then you write to a single table like pizza, 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 as you saw before. If you do that when you write, then you can perform this API side joins or application side joins. You can do them in parallel, while the joins of a relational database usually have to be executed sequentially. So you cannot do a join before the previous one is finished, so to speak. Not only that, but usually, as we said, it's write can wait a bit longer than reads. And this is a design that sort of goes hand in hand with this point, because at the end, every read that is slow is a customer lost, and a customer lost to competitors is not good. And you might also complain, yes, but now I'm duplicating data. I will spend a lot of money on hard disks. Who cares? Our hard disks are cheap, right? Storage is cheap. Losing customers isn't. So that's a bit of a practical motivation. Obviously, there are some drawbacks, because once you are responsible to maintaining this duplicated data coherent, then it's you. Your drivers or your application will have to deal, for example, with writing in multiple places the same data. Yes. but we are grown-ups, and that's a price that we are usually willing to pay for the sacred sake of having faster applications, right? So performance, important. Okay, so this point of the normalization is very important. And we can summarize it like this. Every column you need for a query has to go to one table, all of them. There will be no joins, and queries are going to be very simple. That's it. So one table per query, as we said. You remember the small sketch that was on the previous slide. That implies that when you're writing the database for your application, you start by looking at the queries, and then you build the tables, because you can't just do joins afterwards, okay? And don't forget, that's a bit odd to relational guys, but redundancy is your friend. So yes, you're duplicating data. No problem, that's okay. So it's a law of Cassandra that every query goes to a single table. And usually, since queries determine the shape of the table, most often it's also that every table is built for one single query. Not necessarily, but usually that's the case, or almost the case. Okay, so that brings to a point. Queries are so important, and they determine the shape of the tables. So we have to look closely at how are tables structured. Okay, so we've been seeing what is the idea and the implication of denormalizing data. I hope that's clear, because that's a very foundational concept. Alex, how are we going on the chat? All good? So, okay, let's move on. Sorry, keys and partitions in Apache Cassandra. So you have seen already something about this. Let's look at it again. Okay, so as we were saying, the structure of a table in Cassandra is a very important point, because it defines what is uniqueness in your table, uniqueness of rows. Not only that, but it also defines how the rows are grouped together and are distributed in the nodes. And it also defines what are the queries that you can legally run on a table, or at least the queries that you can run on a table in production without, grinding your cluster to a painful stop, a painful non-production kind of performance. Okay, so we have to have a bit of a look at the tables, and let's go. So let's start with a familiar concept to relational database experts: uniqueness. You saw this morning that a table in Cassandra is a table in the usual way. So it is like a spreadsheet. No, it is a series of rows and columns, like you see here. So there is here a sample table. We stay in the recipe example, and now I'm thinking of an application that is a bit like a YouTube for recipes. So there are recipes, and there are food experts who leave reviews on recipes. So you see there are various reviewers leaving a rating and a comment to pizza and cake and other recipes on several dates. That's a simple table, a sample table, and it's very good to use this as the running example throughout this presentation. Okay, so back to uniqueness. We want to be able to store rows in this table in a way that and we have to determine a primary key that is a choice of columns that defines uniqueness of rows. What do I mean? I want to be able to store different reviews in different rows without one overwriting the other. On the other hand, I want to be able to, I don't want to have several rows by mistake, several different rows that actually are the same review. So I have to choose not too many, not too few columns in the primary key. The principle is that I cannot have two rows with the same primary key values. And look at this table. I have recipe name, pizza, for example. I have a date. I have the reviewer name, such as Anita, Carl, etc. I have a rating, and I have a comment, which is a free text field. And this table, reviews by recipe, has not a primary key yet. Now, what are the possible choices for the primary key? Let's have a look. I could choose just recipe name as primary key, but remember that I cannot have two rows with the same value for recipe name. So that rules out this choice, because you see, I have 3 different reviews by different reviewers on pizza, and I want them to be 3 different rows. So that's not good. So for the sake of uniqueness of rows, I want to add reviewer at least. So every row has a different pair recipe name reviewer: pizza Anita, pizza Carl, cake Poldo, and so on. So that would be good. Let's think about adding rating as well, but that is a bit strange, right? Because I cannot, it doesn't make sense to have the same recipe, the same reviewer, maybe the same date as well, and 2 different ratings. So is the rating 8 or 2? So it doesn't make sense to have everything equal except for rating. So I will not add rating to the primary key, because that's not the word I want to describe. But now the question is, recipe name reviewer or recipe name reviewer and date? That's actually not, well, basically it's up to me. So what is the application? What is the kind of word I want to describe? Or better, in my application, are reviewers allowed to leave several reviews for the same recipe in different days? Yes, no, it depends. That depends on me designing my application. So this choice will have a consequence on what is the primary key. So whether I allow or not to basically store the history of ratings by the same person on the same recipe. So let's say that we want to store the history. So we will allow a reviewer to leave several ratings on different days to a given recipe. So primary key will be these 3 fields: recipe name, date, reviewer, which I mark in blue just to make it clear. Now this table is starting to look like a proper table, right? And if you see, there is no triple of values, which is the same on different rows. Very good, uniqueness. Okay, so there is a point, obviously. If I want to insert a row or even update a row, I will have to provide these 3 values, because otherwise I'm not identifying a particular row. This is a concept we saw this morning already in the little exercise we did. Okay. Now, maybe I will skip this point. Okay, no, let's just mention it. Now you see I'm using recipe name, just the word, the literal string pizza as the field, the value of the field. I might want to introduce a recipe ID, which is referenced in a table that associates this ID to pizza, another ID to cake. That's okay. So the choice between organic or surrogate keys is really up to us, and it depends on what are the exact pathways, the exact access patterns my application needs. So, okay, let's just go ahead. Today we will just stick to the organic key, and we will use pizza itself for the sake of simplicity, but that's really not compulsory. Okay, so much for the primary key. Now let's look at partitioning, which is a Cassandra specific concept. Okay, so there is a subset of the primary key fields, at least one of the columns, but maybe more, maybe all of them, which is the partition key. And that is a concept that you saw this morning, and it is the partition key decides how the rows will be grouped together and how they will be distributed and scattered through the cluster nodes. Basically, you saw that different rows with the same partition key value will always be together, while several partitions are in general spread over the nodes in the cluster. And this is not just a hidden technical detail with deep in the belly of the Cassandra architecture. On the contrary, this has very deep implications on your data model. And you have to be very careful about that, because that's one of the most important parts. So let's look at an example. We had this table, and you remember that recipe name, date, and reviewer are the primary key. Now, let's say recipe name is the partition key, which means that every row about pizza will be, so all the rows about pizza will be together, all the rows about salad will be together, and maybe there will be on another node. So what you see here is a 7-node cluster. And well, it's probably a mess to look at these, because we have a replication factor 3, which means that every partition, so what you are seeing is a single table, but every partition is repeated on 3 nodes. So, and that's good, that's production. But today I want to lower replication factor to 1, so it's a bit easier to read. And here we go. So I have all rows with pizza grouped together, because pizza recipe name is the partition key. I have all rows with pasta grouped together, and so on. Now, I also have, if you look at the lower right, there is a node hosting both the pie partition and the fish partition. That's not a problem. So usually you have several partitions on a single node, yes. What you will never have is one partition split, and half of it on one node and half of another node. That will never happen, because that's the essence of partition. The essence of partitioning is all rows with the same values are together. Okay, so this is what we said. We'll not spend time on these, because this is basically what Alex explained this morning with the partitioner, the hashing algorithm, and the token ranges. A very important point is that your queries will always have to look at a single partition in order to be performant and to be able to scale with a large number of nodes and to be constant access time, sorry. Okay, let's look at the same table. Well, basically the same table, because it's the same primary key, but I just choose another partitioning. Now, you might appreciate that this is the table partitioned by recipe name, and this is the same table partitioned by recipe name reviewer. If you look closely, the way the data is scattered around is completely different, because there's a different partitioning. So now the groups, the partitions, are couples recipe name reviewer. So there will be a partition of salad Aldo, another one of pizza Zoe, pie Ken, fish Carl, and so on. And generally speaking, this will be many more smaller partitions, probably, I can guess. My point is that the way the same rows are placed and grouped here is completely different. And since your queries will have to go and get a single partition, now you see that depending on your query, you will have to choose a different partitioning. So different queries usually means different partitions. Now you might ask, what is the right choice for this table? Well, that really depends. What is your query, is the question. So if you know that you want to get all pizza reviews at once, you will have to partition by pizza. If your application only ever needs to get the reviews for a given recipe by a given person, then probably you might want to choose the second way of partitioning, so by recipe name and reviewer. And that's really depending on what your application is doing, what kind of queries it will need to run. And there is a consequence of this. There might be the case where you need to do different queries on the same data. So you have your bunch of recipes and you want to group them. You want to get all recipes about pizza, but at the same time, you want to get all recipes, all reviews by a reviewer, by Anita. So if you followed so far, you might imagine that there is no partitioning able to satisfy both. Indeed, why don't you create two tables? That's it. And that's exactly what you are supposed to do. You just create two tables, same data, different partitioning, and the two kind of queries will be run against either table. That's it. Remember that duplicating data is absolutely okay. No problem. Performance. Yeah. And that's the point. So you can see now why relational trained engineers find it sometimes a bit odd. But this is really the way to go. So in this sense, it's not only one table per query, which is unavoidable, but in most cases, it's really one query per table, such as in this case. Remember that your application will need to write pairwise. Every time there is a new review, it will have to write to two tables. Yes, that's the price to pay. That's not a big problem. Okay, so now let me remind you of a couple of points, a couple of possible problems that you saw this morning already. One is that sometimes your partitioning makes for a very uneven distribution of data in terms of quantity and load. So I don't know about you, but I like pizza much more than soup. And I can imagine that in our website about food reviews, if I partition by recipe name, the partition about pizza will be constantly accepting new writes all the time. It will be a big partition, constantly being written, while maybe the soup one will be just there, small, idle, easy. And this is the problem of the hot partition. So because there is an imbalance in the distribution. And this is a point to be careful about. And when it comes to modeling your data, this is one of the analyses you should do before before starting with your application, when you model the data. There is another problem, which is, you remember this morning, it was in the example of the IoT sensor table. Let's say I have partitioning by recipe name and reviewer, and the years go by day after day, and reviewers leave more and more reviews all the time. Well, maybe this is not the case for reviews because you can support a lot of rows, but theoretically, at some point, there will be partitions that grow and grow and grow, and that's not good. At some point, I hit physical limits. Partitions should not be too big. The solution you saw this morning is the bucketing. So I can invent a new column like this year, month, string field. They just constructed starting from the date column, and I put it into the partitioning. So I will sort of jump to the next partition every month with the guarantee that no partition will ever grow forever. Now, that means different queries, yes. And this is a compromise to keep in mind, but probably in my application, I can afford fetching 1 month after the other. I will probably not need to fetch all the history forever of the pizza by card. So that's usually an acceptable solution. Okay. So partitioning. You need to know your partitioning and to pick the right one for your application. Otherwise, your data model will suffer and will be suboptimal, to say the least. Ideally, you will never have a query that looks at more than one partition, which is summarized by the mantra, store together what you retrieve together. You saw this morning, and that's absolutely true. You should not design partitions that are too big. So you see there are some limits that are better. It is better to steer clear of those limits to have best performance. While on the other hand, if you have 1 row per partition, that's okay. That's no problem. So you can have a lot of partitions, really a lot of partitions, no problem. Indeed, every time the partition key is the whole primary key, you will have by definition 1 row per partition, and that's absolutely fine. And then you have to be careful of having the way the data and the load, and the write load is distributed should be as even as possible between partitions. And that's it. So these are all things to keep into account.
Stefano?
Yes.
We have a very good question by Cheshire John. We actually should have mentioned already before, but better now than never. So, question is, when you do bucketing, in an example like that on pizza, would you do it on a new table or modify existing tables with that solution?
In a sense, I would say that's already a bit too late.
Yeah.
If you, so to speak. Yeah, that's a, I don't know. Do you want to
yeah, I
okay.
can take it.
Yeah.
Situation is way much easier than it looks like. You cannot change any part of a primary key. Neither partition key nor clustering columns cannot be altered. So alter table exists and it is available, but it can change only data columns and primary key columns cannot be changed. Reason is very simple. Cassandra is designed to work efficiently with big data, and there is a problem. Partition key defines how data is spread over cluster. A clustering column defines how data stored on a disk. Changing on the clustering column would require to rewrite whole data of the table all across the cluster. That can basically will make your nodes busy for ages. And the same
petabytes.
And the same
with
right. The same with the partition key. Changing of a partition key would lead to repartitioning data all across the cluster, which basically can take a week. And there is no way to change per primary key. So if you, that's one of the reasons why you should think ahead and do your data model ahead. First, think ahead and design, and then do. And if you, you see, the point is like it's inevitable to have some changes in the end. For the really simple reason, because that's like business changes, requirements changes, new users, new workflows, and so on. So at some point, you will find out yourself you have to migrate the data. Yes, you will have to design a new table and migrate the old data to the new table. It happens. Okay, that means bucketing should be part of the initial modeling of the data. Yes, exactly.
Yes. Now,
very good question. Thank you.
Yeah, thank you for the good question. And let me just stress this point. Spending a bit of time on data modeling is always time well spent, because if you think about the cost and the pain of a migration live without downtime, with your application already running in production, it's really time well spent if you really plan well your data model, let's say. Yeah, but very good question anyway. Okay, so that's about partitioning, and let's look at the other part of the primary key. So primary key has different other columns that were not in the partitioning. So they are called clustering columns, and they determine how the rows are sorted within the partition. So in our case, we had recipe name, date, and reviewer for the primary key, but recipe name is the partition. So in a partition, we always have pizza, 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 pizza. Now, date and reviewer will be used to keep the rows with pizza sorted one to each other. So if you look here, clustering columns, date, and reviewer will be used to keep the rows sorted, first by date and then by reviewer, either ascending or descending. But the point is that even in the belly of Cassandra, in the files that at the bottom of the ladder are the physical ways, the physical medium the rows are written, even there, the rows within the pizza partition will be sorted by that. And Cassandra, you remember, wants to be very fast at giving your data back to you. So Cassandra will make it possible only to browse the rows within the partition sequentially. But so Cassandra scrolls through the partition in the clustering order only. That means that yes, you have an astonishing performance in reading, but you are pretty constrained in the way you want to get your data within the partition. You can't just jump here and there within the partition. You have to look at sequential blocks of rows within your partition. All of it, part of it, that's okay, but still in that order. So again, how would you choose the clustering? You look at your queries. So if you want, so let's look at these two examples. I have recipe name as a partition, so I have a pizza partition, but now my application might need to get all pizza reviews from a given date onward. Or I might want to need all pizza reviews by John. Those two cases require the same partitioning, but a different clustering, because in the first case, I will put date first in the clustering columns, and in the second date, I will put reviewer first in the clustering columns. Because think of the constraint. I have to go sequentially without holes, without jumps within the partition when I read. Okay, so that being said, this is a create table statement in CQL. You saw CQL this morning. Actually, we ran a few create table commands. This is how they were. Now, create table name, then there is a list of columns name with their type. And then there is this primary key statement. And you see a primary key specified the primary key in that order. And in the recipe name part, you see is enclosed in additional pair of parentheses, which means this is the partition key. Then I can also specify the sorting order of the clustering column. So this is how I would create the table, this example table. Okay, so you will see that even the clustering order is defined when you create the table, and then it cannot be changed because that would imply rewriting all the storage, and that's absolutely not something that scales at all. Okay, so a quick summary of this section. You have the primary key that is connected to the uniqueness of rows within the table. Part of it or all of it is the partition key, which means how the rows are grouped, and within every group, every partition, the sorting, the ordering is determined by the clustering columns. And that sorting will be followed when you read rows. Okay. So now that the structure of the table is clear, let's have a look at what are the implications for querying. And let's start with writing. So you are writing data on the tables. This is something we did this morning. We wrote a handful of sample rows on tables. But first I have to say one thing. For Cassandra, writing just means writing. So what I mean, if you insert data or update rows, it's the same. Almost. Okay, let's forget about counters, which are a special kind of column. But if you forget about counters, writing is just writing. So inserting and updating are just absurd operations. That means that Cassandra wants to be very fast in writing, right? So it will not usually check if the rows is there or not, and maybe give you an error. Oh, look, the row already exists, you cannot write. No, it will not do that. Nobody will tell you, wait, this record exists already. It will just write. And if necessary, it will overwrite and replace the value, because last write wins. Another point is that when you insert or update, which is the same, basically, when you insert a row, you will need to provide the full primary key, because you have to identify that particular row you want to insert, plus other data columns. So you see, this is a typical example of an insert, nothing new, you saw that this morning, so I will go ahead. Let's speak about reading data. So reading is done with select. Also, we saw this morning a few examples of select. And well, on a first look, select statement in SQL looks really much like SQL select. Select fields from table where some conditions. So this is how you get the reviews for pizza. Everything is good and nice and everything. That's it. But besides the syntax, there are very many constraints that your select has to obey. Which ones? Well, your query has to go to a single partition, and when you read from a partition, you will have to browse results in that particular order, in the clustering order. So what do these two constraints mean? Well, in particular, let's look at the where part of a select. So here, sorry, I'm coming back to the slide. You see there is a where recipe name equal pizza. And that's good, that works. But let's have a closer look. I want to go to a single partition, or every query has to go to a single partition. That means that in the where part, I have to specify the whole partition key with equal signs. So recipe name equal pizza, for example. Now, I can specify clustering columns if I want. I can also just leave the partition key, and that's good because I'm getting the whole partition. That's okay. But if I specify clustering columns, I have to, if I use a clustering column, I also have to use all of the most significant clustering columns, the one on its left. And only the last one can have an inequality sign. Otherwise, there have to be equal signs. Okay, that might sound a bit theoretical, but the point is that I can only use where clauses that make the query fetch a contiguous chunk within the partition. So remember how the clustering works, and that defines what kind of where clauses I can use. And by the way, you just cannot use any other column in your where clause. So that's very much different than a relational database, right? Okay, so by the way, there is a way to bypass these constraints, and this is the infamous allow filtering parameter. That's obviously something that you probably just want to do in testing or for very small tables in controlled environments. This is sure not something you bring over to production, please. So let's not even consider that too much today. Okay, so where clauses? The whole partition key with equal signs. If clustering columns, then all of them until up to a certain one, and equal signs until the last. So with the exception of the last clustering column I specify. That's just because of the underlying sorting within the partition. Okay. So here you see 5 different where clauses relative to the table you see here on the upper right, and they are all good. So the first one, recipe name equal pizza, good. Equal sign on the partition key, good to go. It will fetch the whole partition, and that's okay. The second one, within the pizza partition, will go for a particular value of the date. Okay, then it will fetch a part of the partition and a subset of it, but a contiguous subset of it. So all reviews with that date by maybe every reviewer. Okay. The third case is a query within a partition, and again there is there is a greater than for the date, and that's okay because again, if you think of the underlying order within the partition, that's fine. The fourth one will have an equal sign on the date, and that's good. And then also a greater than on the reviewer, but that's okay. That's okay because, again, it will go to the partition and fetch a contiguous chunk of rows. If you think about the clustering order, that's legal. Same goes for the last one that has two different inequalities. It has a range query on the date. That's okay because date is the first of the clustering columns, and I can just specify a range in it. So those are all valid legal where clauses. Let's look at these ones. Let me tell you, every one of these queries of these where clauses fail for one reason or the other. The first one looks at a column that is not even in the primary key, so absolutely no. The second one, the same, even if it specifies the partition key, still it is rating equal 9. That is just not acceptable. That is not how query works in Cassandra. The third one is an unequal inequality on the partition key. That's not good because, again, this is such a query would have to look at potentially a lot of different partitions. So no good. The fourth one, now that's interesting because yes, it goes to a single partition, but then it skips the date, which is the first clustering column, and just goes to the reviewer. And again, think about the clustering order. That would mean taking records within the partition with holes, leaving holes in the middle. And that's not accepted. The last case, again, is basically the same with an additional inequality on the date, but that's not okay because date should have been an equal sign to work. So those are all wrong. Too bad. Okay. Well, this is just the full syntax of the select statement. It looks very much like SQL, but many of the parts of this statement will carry their own strong constraints. So really, this is, in a sense, the similarity between SQL and CQL is sometimes very much misleading in a sense. Okay, so summarizing about reading and writing. Well, writing is easy. Insert are the same as updates, and you have to specify the whole primary key if you want to write a single row. Easy. Reading has to obey several constraints because of the underlying structure of the tables in Cassandra. You have to specify the whole partition key in your where. You cannot use other columns, and you have to keep the clustering order into account because this is the way rows will be browsed and returned. And Cassandra doesn't want to skip throughout the partition. So you see there are a lot of constraints. There is a lot of dependency between the table structure and the queries that you can run on it. So when back to the problem of designing the right data model for your application, you remember that we said you first look at your application, you determine the queries that your application will need, and then you design the tables. I think now you see why, because yes, Cassandra can be very fast and very performant, but you need to know how to use this. And this is how. This is the reason. Okay, Alex, how are we doing?
We are good.
Very good. Okay.
Well, there are some questions, but answered already.
Okay, thank you so much. Okay, so we are ready to look at the conclusion of the ladder. So the highest point in this tower. How do you actually model your data for your application? Well, data modeling in Cassandra is a bit of a science and a bit of an art. Well, there is much science because there's a well-tested algorithm, if you want, a series of steps that will guide you through the right process. But there is also an art part because there will be some choices left to you in finalizing this process. But basically, broadly speaking, the process follows this flowchart. You start by by writing your entity relationship diagram, much similar to what you would do in a relational database approach. But at the same time, you look at the workflow of your application. And that's actually one of the starting points. So you study your application, how it works, what kind of queries it needs. Indeed, when you start connecting your entity relation diagram and your application workflow, you basically apply a mapping between the two that leads you to identifying the queries your application will use. Then the next step is clear because you have your queries and they will probably warrant a table each one. So each query will need a table in general. How do you create the table? You look at the query and you apply a series of steps, which bring you to having a first draft of each table, what is called the logical data model. Then it's a matter of making it physical. So from the logical data model, you finalize a few things, you do a bit of checks, and you basically attach data types and similar things to your table, and then there you go. You are ready to create your table, your tables. So let's look at an example. Guess what? The example of the recipes and the reviewers. So let's start with the conceptual data model, which is, you start by looking at what are the entities in your application. So in this case, we have recipes and reviewers, right? And we also have relations. That's very similar to what you would do in a relational approach. You have recipes with their properties, such as name, preparation time, whatever. Reviewers, they might have a picture URL, a description, a name, an address, you name it. Relations also might have attributes. So a review might have a rating, a date, and so on. And so this is the usual thing you would do. In the meantime, at the same time, okay, let's skip this. At the same time, you look at your application. So I'm thinking of a website where a visitor to this site wants to see all ratings for pizza. Well, that's a query, basically. That is the query. Give me all reviews for a recipe, probably sorted by recent first, so sorted by date, probably. I can imagine this application to make sense. Then the user sees a page of results, pizza recipes, one after the other. They might want to click to the name of a reviewer, either to see all reviews by this reviewer, so all reviews by Anita, or maybe also to see the information of Anita, so profile URL, address, I don't know, score, whatever. So you see, I'm identifying a flow, an application workflow, so a series of different queries, and one leads to the other in the way the user moves through my application. Probably each one of these blocks is a query, and each one of these queries is a table. Indeed, it is now the time to look at one of these queries, each one of these queries, and consult the entity relation diagram and write the table. So let's look at the first query. Select all reviews for recipe name sorted recent first. Okay. So this is the query that will be supported by the table reviews by recipe. Let's look at this query more in detail. I can tentatively write that as a SQL query. So it would probably be something like select reviewer rating command, whatever I need from this table. Now look at the where clause. It would be where recipe name equal pizza and date greater than something. Yes, makes sense, right? So I want all reviews for a recipe. Well, recent first, probably I can put a cutoff on the date. So date greater than something sounds reasonable for my application. Okay, now, and a similar process for the other queries, but now let's concentrate on the first one, because now it's time to make this query into a table. Indeed. You look at the query and make a table out of it, at least a draft of the table, what is called the logical data model. Now, look at the draft here in blue. That is what is called a Chebotko diagram. And basically, it is a Cassandra-specific notation for expressing the shape of the table. So columns are given one below the other, and there are these symbols, K and C with arrows, that specify partition key and clustering columns. Okay, so that's it. How do you reach this table? So how do you write down that particular table? Well, you look at the entities you need from the query. So what are the fields you are selecting? And that's one point. Then you look at the equal signs in the where, which are becoming partition key fields, because, you know, partitioning, you need to fetch a single partition and so on. Then you look at the inequalities in your query, which translate to clustering columns. You check the arrows, so whether they have to be ascending or descending. And that's not the end of it, because there is no mention of reviewer in the primary key, but still we know that reviewer has to be in the primary key because, well, otherwise uniqueness doesn't work. So we add reviewer to the primary key as another clustering column. Well, that's it. That's basically it. And I have this algorithm told me how to create the draft for my table, this logical data model. So it's a bit of a deterministic procedure, if you want. Now, that's not exactly that, because there is much more to do. So, okay, we have this draft of the table, logical data model. Now it's time to make it a bit more practical, more physical. So I have to attach data types. You see now recipe name is a text, date is a date, rating is an integer, etc. So I'm starting to make it to make this table a physical thing. And that's where I have quite some freedom of choice, actually, because, well, in making the table a physical table, there are many kind of considerations to be done. First, I have to remember all of the possible pitfalls. Hot partitions. Are partitions too big? Will they become bigger and bigger in an unbounded manner with time? So some of the problems we saw. And there are techniques to estimate the size of your partition and what to expect, whether the load will be evenly distributed and so on. That's not all, because actually there are various ways of handling. So Cassandra supports several ways to implement one-to-many relationships, so to speak. I can have several rows with the same partition key and different clustering columns, and that's sort of a one-to-many relation, right? So the relation between pizza and the ingredients, or pizza and the reviews, is a one-to-many, and it is just absorbed by the denormalization approach. But in other cases, I might want to use different ways to express a one-to-many. Because you see, besides the primitive data types, such as text, integer, and so on, there are also composite, so collection data types. And these are other ways to express one-to-manys. Let me jump to these slides about data types, that just to stimulate your curiosity. But look at the various types that Cassandra has to offer. Besides the usual text, float, Boolean, integer, and so on, there is also binary blob, which comes handy. And then there are date, timestamp, some identifiers that you saw this morning. And that's not all. That's not the end of it. So there is also a series of collection types. Look on the right. You have list of dates, set of floats, map between text and integers, tuples. So you have various kinds of collection types, and you can decide that a given column is a list of strings, and that would be one column. So in some cases, you might want to have a table of ingredients per recipe, where every row is a recipe, and there is a column that is a set of text, which would contain all of the ingredients. Why not? So there are various ways to handle one-to-many relationships. One of these ways is you can also define user-defined types. So look at this create type reviewer. You can define in that key space that there is something called reviewer that is made so-and-so, like a bit of like a struct, no? And you can define a column to be of type reviewer. So these are these are the typical ways you can be creative when you want to structure relations in your Cassandra tables. So all of these goes to the optimization part. So all the way to having a physical data model, which is finally what you see here on the right. So finally, our reviews by recipe table has become a completely determined table for Cassandra. Here, the only optimization I choose was to make rating a small integer because I don't want to waste bytes. And I know that the rating is always 0 to 10. So I just want to allocate some bytes less, just because. And you see this Chebotko diagram is the same as the create table you see on the left. So that's the end of the journey. And that's how you end up with the actual create table statements. Ta-da! That's it. So you see, this is the typical workflow when you are new to an application and want to create your data model to make it work. So let's summarize this. The very important point is that you start from the application and then you end up creating the table as a consequence of the application and its queries, because it's the queries that will tell you how the tables will be structured. For the partition key, because what are the rows that you need to get all at once? For the clustering columns, because you might have requirements of sorting and of subsets, chunks within the partition. And also for the other columns, because what are the fields you want to get from the queries? So all of these will go into the choice of the table. Then there will be performance considerations for the physical data model, the optimization part. And as we said earlier, time spent modeling your data is, generally speaking, time very well spent. That's the bottom line. Because changing afterwards when your application is already running and you cannot afford downtime, it can be really an expensive operation, let's say. Okay, so I think this was the most important part of this presentation. And Alex, I ask you, how are we doing in the chat? If there were interesting questions.
No, we are all good.
Oh, great.
And
okay.
Just Adrian said what he didn't study the denormalization before, so he is happy to attend this workshop.
Ah, very good.
We are happy for you. We are happy what you attended it.
Yeah, and obviously that's not the end of it, but we will give you more pointers to further continue your journey. Yeah, we are almost at the end of this presentation. Let me just quickly go through some other tools that you might find useful in your data modeling adventure. One is absurds. Well, one is the so-called lightweight transactions. So we've been stressing the fact that inserts and updates are the same, and that Cassandra generally does not bother to look in your table when you write, does not read before write. And that's for the sake of speed and performance. Now, I can appreciate there are cases where you really want to read before writing. So there are cases where you don't want to overwrite a row if it's there. There are cases where you want to update a value only if the previous value is so and so. Yes, there are such cases because the real world is the real world, no? Now, it's generally a very bad idea to handle such read before writes on the application side or the API side for that matter. That's because there might be concurrent accesses to your table and you might have race conditions and you might have inconsistent results at the end. So if two reads before writes happen in a overlapping way, you might end up losing some counters, for example, losing some values or overwriting by mistake. And then what do you do? Well, there is a way. There is the so-called lightweight transaction. So look at this statement. You insert values on a table, and then look at this part, if not exists. So now we are able to tell Cassandra, write this row on this table, but only if there was not such a row yet. Only if that primary key was not a row so far. Indeed, such a statement can result either in a yes, I did it, or I couldn't. So Cassandra will tell you, yes, I inserted, or no, I couldn't insert. So there is a way to kindly ask Cassandra to read before write, to check before doing the operation. Yes, there is. And on a similar note, you can also update a value only if the previous value was so and so. So again, you see update, blah, 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 if rating equal to. So only if rating was previously 2 will this update succeed. Otherwise, no row will be touched. So yes, there is such a thing. And there are specific use cases where this is very welcome and it is to be used. So the typical case is user creation, password changing on the user table, something like that. But it's very important. So these are the so-called lightweight transactions, or also called compare and set transactions. But these are not transactions in the full relational database sense. Well, one point is that they are performance-wise, they are heavier. So contrary to the usual way Cassandra works, these require nodes to speak to each other and to agree on something before actually going ahead and writing. So this is slower because there is a particular protocol to reach consensus among nodes. So this is slower, and that's unavoidable. And the other point is that when you say lightweight, it's not performance lightweight, it's guarantee lightweight. So you don't have the full database lock as you would have in a relational database. There is no rollback. So only a local kind of lock occurs. But the very important point is that it's a performance. So it is not as fast, as lightning fast as the usual Cassandra writes. So my point is, yes, be aware that you have LWTs and be aware that there are cases where these have to be used. But let's say that if your data model relies on them as the main pillar, you probably have to reconsider your data model. Okay, so that's it. That's one thing. Another useful thing is batches. I just want to mention them. So batches. So far, you've been seeing single statements that were widely shot at Cassandra, and Cassandra executes them and give me an OK, an acknowledgement according to the consistency level and everything. So far, so good. But there are cases where I want to group statements together, send them all to Cassandra, have Cassandra execute them, and get something back, right? Yes, there are such cases. And this is very much that it is easy to misunderstand what are batches in Cassandra, because these are not a way to, do bulk insertions and spare some bandwidth in communication. This is really not that. So batches, yes, they allow you to group statements together in a sort of atomic way. And yes, there is less network overhead. And there is also a strong retry mechanism that basically ensures the whole batch succeeds. And it's atomic, but it's not isolated. So, and it's not a transaction, so there is no rollback. And the writes still are executed one by one. By the way, in many cases, order is not guaranteed. So you might end up in an so there might be some milliseconds where some of the instructions in the batch are have succeeded and you read them back and the other don't, and you don't even know which ones. So please be careful, read a bit about batches before starting to use them. And most important, be aware that the proper use cases for batches are cases where you go to a single partition or you go to a single node. So if you have two twin tables with the same partitioning and you want to do a parallel double write, that's a good case for using batches. Like here, I have two different reviews table just with different partitioning, or better, with different clustering columns for some reason, and I want to just do the write simultaneously in parallel. That's a good use for batches. That's because look at the partition, it's recipe name in both tables. Very good. So I have the guarantee that I can group those two inserts in a batch and it will reach a single node. Nice. Similarly, if I have a table and I want to write several rows on the same partition, again, I can close them in a batch, shoot the batch at the cluster, and I will be sure it will reach a single node. So again, performance is unaffected and it's good. When batches start to be used in different ways, sometimes it's something that you want to do, but just be aware that implies some performance degradation. And in particular, never think of batches as your gateway to just run, to just wrap together some statements and just execute them, because that's absolutely killing the performance. Every time a batch has to speak with different nodes, that's not only is a slower kind of thing, but also internally works in a different way. So this becomes a logged batch, which works by storing a log of the operation to execute, then execute them, then deleting the log, and that is basically connected with the strong retry mechanism. So yes, again, use batches if you want, but that shouldn't be the whole foundation of your data model. So usually you are able to find a better data model that does mostly be without batches. Okay, so there is something else to just mention. A nice feature of Cassandra is the time to live. That was briefly mentioned this morning by Alex in connection with the ever-growing partition problem. So besides bucketing, you might also want to use the time to live. You can when you insert data, or you can also write update, you can set a time to live in seconds to individual cells, and automatically after the given amount of seconds, reads will not give you back this data because the data will be basically forgotten. That is useful to keep size under control and other usages, sure, but be careful because time to live is always per cell. So you might risk making different writes and having a row with different time to live. And then some of the cells, some of the columns are disappeared, the other haven't yet, and you find mysterious partial rows in your table, so rows with some cells only. The other risk is that you might think that time to live means that the data disappears and the disk is freed. The disk is magically free again. Well, that will happen, but you don't have control over when exactly. So you don't have control with time to live. So time to live is a guarantee that when you read and the time has expired, the data will not be there, but that's not the same as expecting that the disk will be actually free. This is something that is a bit handled a bit internally within Cassandra. So don't be so relying on that for keeping your disk space free immediately. Okay, so another topic is indices, and that's a surprise because so far we've been speaking almost 2 hours as if indices this did not exist. So I've been keeping I've been telling you all the time, build the 2 tables, create several tables, and so on, while indices exist. So you can have a table and you can read, you look at this example. There is a select that doesn't work because reviewer is not, so this where clause is illegal, the first row here, and indeed you get a nice red error. Then you create an index on this table on the column reviewer, and the same query now works. Wow. So indexes are there after all. Yes, they are. But there are some constraints on what columns are good candidates to be indexed. And don't forget that indices, the data composing the index is distributed not according to that field, but according to the base table. So you might have some non-trivial interplay between the two. So what's the point? Again, yes, indices are there, and in some cases they might be useful, and it's very important that you have a look and look carefully what they do and when they are useful. But in many cases, remember that disk space is cheap, and probably in most cases you are better off by just creating another table and keeping them in parallel. Okay, so it's quarter to, let me see, quarter to 5, I think, out there. Here it's quarter to 8 in the morning. And come to my conclusion. Well, what you saw today is a first adventure in the realm of data modeling with Cassandra, but 2 hours are not enough to go much in detail. And I really encourage you to find out more because it's very cool and interesting, and because it's very important if you want to be serious with Cassandra. And we have a lot of resources to explore further. We have hands-on exercises that are very good, and they work with these interactive scenarios and you do all in the browser, and they are real use cases that are analyzed in detail, and you will be guided through basically creating and studying the data model for real cases such as sensor networks and so on. We have the Academy, DataStax Academy, with classic courses about data modeling, and they are part of the study program to get the developer certification, by the way. And you also have other resources such as a mailing list to be informed of our workshops. We have workshops. Reach us on Discord, and please don't hesitate to ask questions on the community datastax.com, where well, it's a bit of a Stack Overflow for Cassandra. So there are a lot of things, and we also encourage you to go to this datastax.com, learn data modeling by example, do some of these interactive scenarios. They end up with a congratulations page. If you want, you can take a screenshot of the congratulation page. You can send that to us. You see here the address. Maybe, Alex, you can drop the link to datastax.com data modeling by example. You should have it there. Thank you. And if you reach us and give us the screenshot, you will get a completion badge. Again, something you can use to brag about. Okay, so this is how the congratulations screen looks like at the end of the scenario if you get everything right. And well, we are a bit earlier, but I think that we said everything there was to say. So I have to thank you.
Great
for
job.
the attention. And yes, go ahead and model your data, create your applications. And by the way, soon you will also see the development part of creating an application. So yeah, that's it. Thank you for the attention.
Yep. Great. And our next step is going to be Ask Me Anything. Well, regarding Apache Cassandra, hopefully. We already collected a lot of questions.
Yeah.
Which is great. Don't forget to ask more. Don't forget to upvote questions you like. And we meet you again, I believe, in 12 minutes.
Yeah.
Amazing. So then, see you soon,
So
and thank you,
please
Stefan.
stay tuned. Thank you. Stay tuned and see you very soon.
All right. Hey,
Hello.
take a
Hello.
look at the amazing team we have here today. Now, please let me check the sound. Stefano, say something.
Hello, everyone.
Okay, Eric.
Happy Freedom Day, everyone. If you're from Melbourne,
Yay!
congratulations.
And my God, Cedric, your
Cedric.
turn. Yep.
Yeah, hello and good early morning if you're based in Europe, like some of us.
Yeah, okay, good. So, looks like we are fine. That means we can start.
Maybe we want to let Cedric and Eric present themselves.
Oh, right. You just wanted to go
I mean, we have
straight
such
to the
a
questions.
precious and honorable guest today in the AMA.
Yes,
So
yes. So, Eric, could you
Awesome.
please introduce yourself?
Yeah, so hello, everyone. I'm Eric Ramirez. I'm based in Melbourne here in Australia, and I'm a Cassandra enthusiast here at DataStax. So I answer questions anywhere and everywhere, Stack Overflow, community.datastax.com, on 6 different ASFs, 6 different Slacks. I think there's 4 or 5 different Discord servers, different mailing lists, pretty much everywhere if you have a Cassandra question.
Including
Right.
here and now.
Right.
yeah,
I do
And
think
I'm Cedric Lundven, and I'm leading the advocacy team at DataStax. I'm Java geek, love coding, geeking, and I do have a little bit of knowledge on Cassandra as well, but not as much as Eric does.
Well, you know what? We think actually what Eric has replication factor 3 enabled because he is able to answer in multiple channels simultaneously.
yeah.
Okay.
Yeah, but is it consistent?
We will see soon. Good. So let's proceed with the questions. And first question we are going to answer will be quite interesting by Tom Kiley. What happens if the hints fill the disk space because another node is down forever? So looks like someone cares about operations here. I love it. If you don't mind, I will take care of it. So idea is very simple. It cannot happen because hinted handoffs have some limited graceful period of time they will be stored, only within, in the current version, 3 hours. And after that, they will be discarded automatically, exactly to avoid the problem raised by Tom. But what do we do with a node if node was down for longer than 3 hours? Answer is there are different possible actions, but in general it all will be all about to run repair, or on some bigger amounts of data it can be easier to decommission the node and bring it back as new. But the situation of hints filling the disk space endlessly cannot happen. But it raises one very important point. What you want to understand if you are responsible for operations and for monitoring, your Cassandra nodes does need to have enough free space, and that's important for operations. So you do want to monitor disk space. Gentlemen?
I mean, you say it all. And you know, it's Eric keep saying that when I'm reading his answer. It's like, when something goes down on a Cassandra node, start to flush and intent and def, and only if it's not only just decommission the node and bring back a new one. Yeah, so not good stuff to hide here.
So, if you don't mind, I will mark this question as answered. Great job, and let's move to the next one. So, this is an anonymous, which is not anonymous because I believe I've seen somewhere it's Johnny Huertas on advantages and shortcomings on Astra. So, gentlemen, who wants to take this one?
I'll answer it. So the general proposition with Astra is one, it's a managed Cassandra as a service, so it's already available. And two, you're not wasting your time, doing the downloading Cassandra, installing it, configuring it, and stuff. Because in literally 5 clicks, as you've seen, if you followed along in the workshops earlier, in just 5 clicks, you have a Cassandra cluster running operational. You can start building your apps. So that's the main difference with using Astra. But if you're an expert, by all means, go ahead and build your own Cassandra cluster. But if you're following us along on this track, I'm guessing that you're not an expert. So Astra is an easier start, put it that way.
Yep. Cedric, Stefano?
I mean, it's pretty complete. Yes, so Astra, easy to use, easy to start. Have more than just Cassandra, also the so stateless API, the one I presented in the other room a couple of minutes ago. And could be cool if you want to build some application using JavaScript, mobile, and do not want to use a driver, but you're the API, it's there out of the box. The issue is it's too easy, so you won't learn how to operate Cassandra if you use Astra only. It's cool because it's free, up to 40 million queries per month. That's just huge. So you can run your a Smoke workload for totally free. So that's
Yes, it may be enough even for small production workload.
Yeah, absolutely.
Right.
What I can add on that, from my point of view, it very depends on which part of Cassandra you are interested in. So if you are a developer, then Astra just may be the best solution, obviously. A couple of clicks and you're already working and it's done. If you are more on the operations side, then that's exactly like Eric said, you are missing all the boring, not boring, but most exciting part of the installation, configuration, launching, building a cluster, and so on and so forth. So you are more into the operations, then obviously Astra as a managed solution won't be a good choice for you. For developers, I definitely can recommend using Astra.
Yeah.
And it's 2021. There's
Yeah.
operators that manage it for you, been replaced by AI.
Yeah. So I might add another thing, that is, there is a shortcoming that very emphatically is not there, which is lock-in, because really, if you write your application working on Astra and then later for some reason you have to, say for data governance reasons, whatever, you have to come back to on-premises, you basically don't have to touch every single line of your application and vice versa. So this is really an important point, because there is full compatibility, and that's a precious thing in 2021.
Yes. Okay, I think this one is done. And that was a really good question, by the way.
Yeah.
We have to mark this one. Good. Krishna Chaitanya asks, what is a stale data and when it occurs?
I'll take it if no one takes it. So that's when one of your replicas, so let's say you've got a replication factor of 3 and one of your replicas was unresponsive at the time that a write was sent to it. So it means that it might have an old version of the data. So for example, if you updated a particular row, so it just means that it will have an older version of the data. So when you read data from it, it might return older data, but that's what the higher consistency levels solve for you. So if one of the replicas is out of date, it will automatically get the latest version through what's called a read repair. But otherwise, if you haven't read the data and read repair hasn't kicked in, then it will get repaired by the normal repair operations that you perform. On Astra, it happens automatically for you. You don't have to do any manual operations in Astra.
Yep. Nothing to add.
That's just say it's really when a node is behind. So as Eric stated, is when replica could be behind, and this is why you would like to use a consistency level that is not one but quorum where when you can. I've seen stale data mostly on materialized view, so use them wisely. Materialized view tends to be a bit late, so it's good for read AV use case. You do have the data, you build the materialized view, and you start query the materialized view, all good. But if you need to update the data, then the MV, as we call them, tends to be late and not fully consistent. And anyway, it's still an experimental features, more or less. But it is where you see, if you use stale data Cassandra, you probably will eat some materialized view talks.
Yes. To the point that in the recent versions of the data modeling presentation, we took materialized views out entirely because of their reiterated status of experimental, even in the Cassandra 4 release. So they actually, today, we didn't even mention them.
Right. Just for full disclosure, because I work with DataStax, so the version of materialized views in DataStax Enterprise is production ready. But we're in the process of porting those fixes to open source Cassandra. It hasn't happened yet, which is why by default, materialized views in open source Cassandra are disabled by default.
Yes, good point.
Okay, then. That's a very good question, which has... first of all, I really like this question because, yes, that's something you should avoid. It's quite sad, it's anonymous. Now, this question, from my point of view, have two answers. And one will take 5 seconds, and next one will take 50 minutes. A short answer sounds, always specify all parts of a partition key in your queries. If you always specify all the partition key parts, components in your query, you always avoid full cluster scan. So it sounds very simple. Now we get to the second part of a question, which I will have to skip because the general idea is exactly as Stefano explained it. You first have to understand your customer behavior, your user workflows, if you use them, user stories to generate these workflow diagrams, and then finally, based on that, you can design proper data model, so you will know your partitions and therefore partition keys, so you will always have good queries and not full cluster scans. That would be my answer.
Yeah. Maybe I can also comment briefly on something that happens in the real world we live in, and that is a small company starts maybe new to Cassandra, and they are just experimenting, prototyping, and they happen to just secretly insert a good allow filtering everywhere in their API, and then everything works because it's a small workload, then things go fast, iterations go fast, and oops, that allow filtering just stays there all the time. And then they hit production and oops, we didn't even think of a data model proper. Now that might seem a very full mistake, but I think it happens all the time in small companies. So earlier during the data modeling process, we said with Alex, spend time on data modeling and you will not regret it. Now, I want to reiterate that now, just as a real life remark.
Time spent on data modeling is not wasted, but invested.
Yeah.
But maybe the person asking the question maybe thinks that when you do a select on Cassandra, even with a partition key, that maybe it's doing a full cluster scan. It doesn't, because the Cassandra knows, the coordinator knows which node owns the partition or which nodes to query for that select statement. So it doesn't actually do a full cluster scan. It targets the replicas of that partition.
Right.
Yeah, if the question is really how to avoid full cluster scan, build your table based on your queries. And if you need multiple queries on the same data, it's very likely that you need multiple tables with the same data. And that's something that you don't do with
Right.
relational and new and maybe, but you know, disk is cheap.
Or maybe materialize views.
2021.
In
And we come full circle.
Right. Okay. So I will gladly take this question because quite a coincidence. I asked it myself this question once and even did an experiment to check the behavior of the system in this scenario. So the question from Jonas sounds like, can you set the replication factor to more than the number of nodes? Where are the records stored then? So answer is interesting. First of all, you can set replication factor more than number of nodes you have. You have a cluster of 3 nodes, you can set replication factor 10, technically. So it will work. You can make great key space, replication factor 10, it works. But then you execute a query with consistency level higher than reachable number, you will get an exception. So in this scenario, if you have replication factor for 10, real replicas available 3, if you make query with consistency level 1, 2, or 3, you will get your data stored. But if you get query with replication factor quorum, which will be 6 nodes in this case, so it's an unreachable state, you will get an exception, can't reach desired consistency level. I even have a video about that recorded.
Oh, cool.
Okay.
It sounds stupid that we allowed that, but there's a reason for it. It's because if you wanted to scale your cluster, then we allow certain, we don't have strict replication. So for example, if you were adding a new data center, to be able to add that data center and run node till rebuild, you need to be able to change the replication settings on the key spaces before the data center is added.
Right.
Good right.
Point.
Good. Okay, so I believe I can close this one. Okay. Oh, that is a question people ask sometimes, and that's a good question we have to answer. But gentlemen, don't forget, we don't have all the time in the world. We have some limited amount of time.
I can do chapter 1.
Let's go.
Okay, so if you look at distributed database, exactly like Yugabyte and Koch wrote, as you stated, those are ACID. So ACID, they handle transaction. And so as a distributed system, they pick CP, so consistent and persistent tolerant, with the CAP theorem. Remember, you cannot beat the CAP theorem. So both of them pick the CP stuff. So that means they are consistent. They can do distributed transaction, which are slow, batches. Cassandra can also do on certain circumstances do transaction at partition level called LWT. But Cassandra works more on availability. You never do read before writes. So it's all about performance and effective writes. So pro and cons, depending on your use case, if you absolutely want CQL because your developers only know that, well, it will come at the cost of the consistency, and you cannot maybe scale out as much as you want. So the advantage of Cassandra is, availability first and scale a lot. You've probably seen some numbers over the day today, like in Netflix, Apple with more than 100,000 nodes. Well, it's pretty hard to do in distributed system transaction if you do a 1,000 node in your cluster.
Mind you, there's an enhancement proposal that's being voted on right now that will change all this in the future. that will have better asset transaction support in Cassandra.
It's coming.
Well,
Yep.
it's probably going to be a rather long process because it's a big thing, but
Yes.
nevertheless.
And no surprise, it will be slow. Okay.
Yes.
Paxos, just a Paxos is 4 times slower than a regular request because it needs to do the prepare commit, validate everything, and only then commit. So it's slower. So that's all about trade-off, performance, availability against consistency.
It's a bit of a law of physics. You can't go faster than a given threshold if you want that to work.
Yes. You see, that's always like you can build a car what goes very fast, or you can build a car what's going with a lot of cargo, but considering limited amount of money, some limited budget, you cannot build cargo car which goes fast because you have to decide, and there is always price to pay. In general, my opinion on ACID in the distributed environments, if you require performance and fast answers, ACID is a complete lie. ACID basically does not work. It's simple as that.
It's an illusion.
Yeah.
But back on Paxos, I understand that if egalitarian Paxos somehow gets its way in Cassandra, that would speed up Paxos, right?
Yes, but
even
still,
though it's complicated to implement because it's a bit more cumbersome to handle, but that is a substantial increase in performance, as far as I understand.
Yes, but to take a look, I mean, anyway, yes, there can be some improvements done, but the general idea is that's like this comparison of multiple writes with denormalization versus multiple reads with joins of normalization.
Yeah, I agree.
There are some circumstances then joins won't be too slow. But normally, in the normal real life world, joins cannot be executed in parallel, and in general, they always slower than multiple writes.
Yeah, I agree completely.
Yes. So,
and they're two different problems, right? You can either have consistency, so ACID transactions, or you can have availability. You cannot have both.
Yeah.
If anyone who's listening to us right now has a solution that gets both consistency and availability, let us know now, because I want to buy shares in your company.
Yeah.
I'm serious. You cannot have both.
Yes. So yes, there are some scenarios when this new SQL, distributed SQL, may work well. Then congrats. Because of all this fancy ACID stuff, it can work, and it will work significantly slower than with Cassandra. So at some point you just have to decide. I'm going to close this one. Okay. This one I have to explain. I believe I remember what is it about. It was about network partitioning and partition tolerance for Apache Cassandra from CAP theorem. So if a partition, network partitioning even a concept in Cassandra, if so, how does it handle it? By the way, very good question. In short, very idea you remember is what you can, you have two levers, two knobs to control consistency and CAP things in Cassandra. One is replication factor and second is consistency level. Take a look. Then remember my example, data center, 5 servers, group A, 3 servers, group B, 2 servers. We have a network partitioning. So group A cannot reach group B. Group B cannot reach group A. First of all, guys, that's a serious emergency. So at this moment, your network engineers must be running and trying to fix everything what possible and reestablish connection. So we speak now about a real emergency state, which can, as I said before, lead you to problems heavier than even a pure downtime. Now, how does Cassandra handle it? Very easy. Cassandra give you a tool called consistency level. Imagine the query we execute at consistency level quorum. That means what we go to the replicas. We will have a replication factor 3, 2 replicas in group A, 1 replica is in group B, obviously. If the query is going to the group A, it will work perfectly because query coordinator cannot reach desired consistency level. 2 replicas for our query are in the group A. It works. So you store data is stored, all good. Then you execute a very same query, but query goes to group B. I don't know, just because of some round robin balancing and so on and so forth. Same query, but now you have only 1 replica in this group B. Query with consistency level quorum cannot be executed, and your client receives here cannot reach desired consistency level, cannot reach our replicas. So, for example, with retry, it can go to a repeat for the group A, for example. You can try to go for it, and this way, this query will be executed for the group A, won't be executed for group B, and this is good. That is very important, what it won't be executed in group B. Then imagine you are doing the same query, you write some data but with consistency level 1. In this case, you may get into potentially very dangerous state. Then information is being stored to group A and group B by different clients separately. And if there is no collisions, if that's a different kind of data, then it's completely fine, because when it will recover after all. But then you work with same data of the same clients with different groups. It can lead to technically to this split brain story I told you already. That's why for most of the cases we recommend to use quorum, because it's able to protect you from this situation. And consistency level 1 is better to use for the kind of data what cannot go into the split brain problem, because it's just like different data from different sensors, for example. Then you can reach consistency, when you can use consistency level 1 safely. Gentlemen?
You covered it. I think the next question is related to it as well. So storing hints is a way for handling network partitions. Because again, as we talked about with the ACID transactions, Cassandra is built for availability and partition tolerance. So you can sustain, if you have multiple replicas, you can sustain outage to nodes. And by default, and in almost all cases, in almost all of the companies that I work with, you need to have a replication factor of 3 for each data center. That's how you handle network partitions.
Okay, so looks like we are done. Will hint contain metadata of the nodes?
Yes.
Okay.
So the hint has the IP of the replica that was unresponsive, so that when the replica goes back online, the coordinator knows which node to replay the hint to, where to send the mutation to. So it has the IP of the replica plus the payload, which is the mutation itself, whatever was being written, whether it's an insert, update, or delete.
Right. Okay. I believe it's more or less the same question, we answered it already. What happens then? Network partitioning happens when a query is fired, or does, so it can happen as explained before. Then partition fault happens when a query is fired. It very depends on which stage and with this consistency level. because it depends, like data partially was delivered but answer was not received. It's one situation. Data wasn't delivered at all to the replica nodes. It's another scenario. In general, of course, I can recommend what if you have a lot of network partitionings, you have to fix your network first of all, because obviously any distributed system, doesn't matter if it's a Cassandra or any other distributed database or not a database at all, very heavily depends on the quality of a network connection.
And it's 2021.
Yeah.
Yeah.
Okay. For the banking service, the database writes transactions need to be logged to track which system updated, what kind of attributes. How can they achieve this in DSE, DataStax Enterprise? And I believe the same belongs to Astra.
I mean, the audit part, the advanced audit capabilities is there for sometimes in DSC already. I think it was introduced in DSC 6. Even for Cassandra, now with Cassandra 4.0.
With Cassandra 4, there is a pretty comprehensive set for
query loading
auditing also. Yeah.
Yeah, where you can track.
So
go for it.
Yeah, Yoshi covered that in the other talk room for the what's new in Cassandra 4.0. So definitely audit logging. And for the record, there are lots of banking institutions that use Cassandra today. ING is one of our big customers, and they use Cassandra, DataStax Enterprise, for ledger transactions. I know, ACID, right? It's an illusion.
Monzo.
Banks use 100 today. Eventually consistent.
Yep.
People say it's not ACID, but it's an illusion.
Yeah. Monzo use only Cassandra. It's just crazy. Monzo, a bank in the UK, pretty famous new gen bank, using Monzo heavily. You can go search for Monzo Cassandra stuff, and you will see they are using it for everything. Maybe at some point, they should split the clusters, but
yes. By the way, regarding these transactions, ACID and things, do you know, actually, you know, but you don't realize what is the, not exactly about the Cassandra, but what is the biggest network without ACID transactions with eventual consistency you are using all the time? ATMs, bankomats, the machines that you get cash, you give your card, you get the cash. The whole banking system is completely eventually consistent and doesn't support any kind of ACID transactions, and it's still perfectly operational. That's just a fun fact about ACID is an illusion.
And now you gave the clue to the magic. That's very disappointing.
Yes. Okay. So, next one is very simple. Can you please explain a scenario where if there is a typo in the search, the record is not present in any partition? How does this search work? Idea is very simple. Doesn't matter if partition exists or not. There is a token range covered by some server in which this partition belongs to, if it would be. If you randomly give a key for which partition does not exist, anyway token can be calculated, and the server responsible for this partition will be reached, and it will answer, there is no partition with such an ID, not found, like the empty answer, no rows, no partitions, nothing. That's completely fine.
Yeah, on top of these default query mechanism, you can create some secondary indexes. So most of them work with exact match. So if you do a typo, there is no fuzzy search. Except on, DataStax Enterprise, not pushing here, but there you do have the Solar index where the Solar features could work on fuzzy, and the index is created with all the fuzziness. But for Cassandra and secondary index could be default secondary index, SASI or SAI. They're all both with exact matching values in the index.
All right.
Or you can use Elasticsearch as well if you want on open source Cassandra.
Yes.
All right. Okay. So.
I refuse to answer this question.
Oh, yeah.
That's it, I'm walking out.
Actually, I like this question, but maybe someone wants to start. Cedric, Stefano?
Eric will wrote a book on these questions.
Yeah, there are many. This is a question that gets asked very often because MongoDB is a database that has great visibility.
You know what? That could be the title of a book. I think it will be pretty well sold.
Yes. Yes. Well, there are many differences. One is the basic logic of being schemaless on one side and tabular on the other side. That's one of the differences. By the way, when we say schemaless, let's say it's a common parlance. The real thing is that MongoDB is, as many schemaless databases, is variable schema. So every single document defines its own schema. And that's one of the differences, even though with Stargate, of which Cedric has given a nice presentation right before this AMA session, with Stargate, there is a layer that makes it possible to look at Cassandra in a schemaless way. That's one of the differences. Another difference is the architecture, that in Cassandra is completely democratic, so there is no master slave, while in Mongo there is a leader follower architecture with periodic elections in case the leader goes down. And well, there are other differences. I leave to you guys to go on with the list.
Yes.
Yeah, I completely understand what the attraction for MongoDB, right? So a lot of developers like working with JSON documents. It's flexible, it's easy, right? But you pay a price for the flexibility, and that is you cannot reach the scale that Cassandra does. That is the biggest difference between Cassandra and MongoDB. One is flexible, the other one lets you do internet scale.
Yes. By the way, I have an interesting point. Take a look. There are three major leading NoSQL solutions: Redis, Mongo, Cassandra. And they all are great if you use them right. So I don't want to participate in the competition that you compare Hammer and Wrench, answering question which one is better. Wrench is better when you need to use wrench, and hammer is better when you need to use hammer. Obviously, they are very, very, very different. They are for different scenarios. And Cassandra is not exactly a competitor to Mongo, and Mongo is not exactly a competitor to Cassandra, maybe in some minor use cases. But in general, that's a competition of hammer to wrench. There are many different, that's what I say about NoSQL. Mongo to Cassandra is way more different than Cassandra to relational databases, by the way. But not about that. Exactly as said already by Eric, Mongo is more for flexibility, you remember this very core definition of why NoSQL was created, like different kind of NoSQL databases were created. Rule of three, variety, velocity, volume. And out of 3V, Mongo stays on the variety. So you can store data in different formats, put documents into the collections, and it's cool if you need that. And Cassandra stays on the side of volume and velocity. And again, it's cool when you need them. It will be a mistake to use Cassandra when you work with small data, but of a very different formats, and you cannot define the structure for them. Okay, but if you going to get the volume and velocity, so high volume, high for output, then definitely Cassandra can be a better choice as long as you can formulate your table structure.
Okay, so okay, I will go last. Like you will get the answer for everyone. So just the differences. So at the interface level, so Cassandra using CQL, Mongo leverage on JSON. Cassandra like to have everything validated and a strong schema. Mongo is flexible. Okay. Then on the architecture, Cassandra pick AP, all about availability, super scaling. Mongo pick CP. You do have a master and multiple replica. The writes will happen on the masters. You can have shadow masters, but it's different, right? It's not masterless. So in the architecture as well. In the storage, so Cassandra storing everything with SS table and append only, always to avoid any read before writes, and Mongo using his own binary storage. So on each step of the stack, there are differences, but as told already by most of my my peers, it's not the same use cases.
Right. Yep. And finally, one last point I forgot to mention. Maybe someone of you mentioned that, and I didn't notice. Cassandra scale for both writes and reads. Mongo scale is good, acceptable for reads. For read, yeah. So if you have write-intensive operations, then there is no competition. Like,
ask you the question. Intensive writes. I put you in the chat. Anything transaction, ACID or master slave. You need to ask you the question.
Yeah. Right. Okay. So I believe we are done with this one, and we have just like very quickly last points. I will start with this one because it's simple. In AstroDB, can we import CSV files to create tables as well? We surely can import CSV files, that's for sure, but I'm not sure if we have to create tables beforehand. I believe we do have.
Yeah, I think you have to, because the CSV doesn't know about what is going to be your partitioning, for example.
Yes, so if you look at the Astra data loader, which is a tool in the UI, it will create the schema for you, but it will ask you what is the partition key and clustering column to save your data as you like. But please create your schema first, because you know what the type should be, what is the partition key, what the clustering column. Focus really on how the data should be stored, and only then import the CSV.
That is well said. Okay, this one. Yeah. Hi, Johnny.
So Tombstones, just really quickly, Tombstones is not a problem if you're deleting the whole partition, so it's not a problem. So let's do the DataStax course.
Yep.
So maybe there is a map, a non-frozen map, and they are updating it all the time, which also is a source of tombstones.
Yep. Tombstones can be a big problem, and exactly like already said by Eric, try to wipe out the whole partitions, then tombstones won't be a problem. Yeah. If it's not in general, just to mention, delete intensive operations, delete and intensive workloads, I in general consider it as anti-pattern for Cassandra because of this tombstone story. So you want to build your queue on Cassandra, definitely.
Yeah. Also, so you do have tombstone at cell level, row level, partition level. So you would like to delete as much possible as you can. So delete per partition is the best, as stated by Eric. Also, at your data model, come on, you just keep appending the data, put a TTL as a clustering colon desk, and anytime you will select, you will get the last. You can also append only and get different version of your data and query the latest. It is called a ledger data model, and then you avoid some delete if this is absolutely the use case you do have.
Okay. Well, if I want to complete a DataStax course and certification on Cassandra, how long would it take to complete, and how many hours a day I need available? We have a dedicated certification workshop starting 3 minutes ago.
On this channel.
By the way,
So
sorry, just one
if
second.
you were really smart,
Okay.
I was just going to say, if you were really smart, you can probably complete all the courses in about 60 hours. And maybe if you're really smart, you can pass the certification, but it doesn't mean that you understand the content. If your goal is to pass the certification, then yes, 60 hours. But if your goal is to learn Cassandra, I would say minimum 3 weeks to a month, but maybe about 2 months to really understand it.
Yep,
Yeah.
but it pays well. So, I mean, yes,
Yeah.
it requires time, but it pays.
Yeah, but considering the question, it seems like it seems like Yoni is working and he's wondering whether maybe a few hours per day would suffice. Probably in that case, a couple of months of moderate effort would do the trick if there is
Yes, it's a
few hours per
self-paced.
day.
Oh, sorry. It's a self-paced course, so you can completely go with 2-4 hours per week, and it depends on how much time do you have completely. But in general, course is quite friendly and doesn't require some too complicated things. So you can make it, and if you will have any problems with understanding, get to our Discord and ask. There are always someone to help.
But
And
please stay tuned.
Also,
the
you know,
next
it's a path. So on the academy, you will find multiple courses. Just with the first two, DS201, DS220, you can have your first cert. Do not expect to do 60-hour Big Bang and pass all the certification. You can, you can have intermediate milestones, but as stated by Eric, regularity, a couple of hours, Monday to Friday, and in no time you will get the first certifications.
Yes.
You know what they say, it takes 10,000 hours to become an expert.
Yep.
Well, we speak about associate level certification, so it's a little bit different. But yes, I know what you mean.
And Eric, if they know it all, that they cannot ask you question, then.
Yep.
Okay.
Okay.
I would say
Thanks,
goodbye
everyone.
and jump on the other room because we have an announcement now. We had to switch the two talks now. So this room will host the certification talk by Alex. And if you want to see see the application development workshop, please jump to the talk room now.
Yes. See you for the workshop, for the certification preparation here in a few minutes, or join Stefano with application development using next room. See you in a moment.
Okay.
See you.
Bye.
I hope you are happy to see me again, because now we will talk about how do you boost your career with DataStax sponsorship program for your NoSQL certification and Cassandra skills. Give me a moment to get ready. Okay, so here we go. Right. And thank you so much for your warm words. We are also happy to do that. And okay, by the way, we just decided in the chat. Okay, not decided yet. I will announce that in a minute. Who is the winner for the questions and answers? Give me a few more minutes. Meanwhile, we will start. So, amount of data in the world grows, and it will only grow. And data-driven companies are getting more and more successful. But to make decisions based on data, you need to have a lot of data. And to store this data, you need a suitable database. Meanwhile, doing that fast and convenient for your customers. So we speak about Cassandra as one of the most popular NoSQL databases in the world. For a reason, of course. DataStax sponsors education and certification for Apache Cassandra. Let's take a look on how do you go through this process. What do you need to know? How do you learn? And then in the end, do a little demo exam. So you will try to answer questions and see how much more do you need to prepare. Short answer is Cassandra Day is great, but you do need to take courses, because that's not enough just to watch those workshops, okay? So let's go. All the materials for this workshop, or all these materials for this session are stored at github.com DataStax Academy workshop Cassandra certification. Today with you, me, Alex Voloshnev, developer, advocate, lead, and DataStax. And we will talk about which certification to take and what resources to use, steps for your certification, run a demo exam, and discuss resources in the end. So first of all, which certification should I get? The point is, there are two main certifications, administrator and developer. There is also a third one available on Cassandra, running Cassandra operations on Kubernetes, but that's a special case, so you better get one of the fundamental certifications and then already consider Cassandra if you are into Cassandra. Very easy. So then administrator certification, designed for professionals who run the operations, install, configure, manage, and tune performance for Cassandra clusters. Obviously, developer certification, designed for developers, quite easy to explain. Now take a look. There are 4 courses at the Academy you have to take, but the first of them is very small, basically. You can do it within 1 hour. So for real, there are 3 courses. DS101 Intro is a very short one. DS201 is the foundations, like the fundamental course. DS210 for operations, and DS220 for data modeling. Now, notice very important point. If you are going for a developer path, then you just follow the developer path. DS101, 201, 220. And you are good, you are basically ready for the exam. But if you go for operations exam, you have to take DS101, DS201, DS210, and I just beg you to take these 220, because you can say what operations in Cassandra is not about data modeling. I know. But anyway, you not always will be working with developers who know what they are doing. Very often developers just go straight, my query doesn't work, add allow filtering, and add one more, and why my database is so slow now. So even if you are in operations, you still have to understand data modeling for Cassandra. So administration path I consider like a harder one. You have to do more, but it's really worth it. So I still suggest to take to 20. What resources do I have? Main page for all the certification information is datastax.com/dev certifications. Simple as that. For the DataStax Academy workshop Cassandra certification materials for this one, already discussed it. And main place for the trainings is academy.datastax.com. Is it free? It is free. Academy has some courses, but first focus on the paths, admin or developer. It will be the very good choice. Now, to work with community, you can ask questions at the community.datastax.com. It's like Stack Overflow, but dedicated to Cassandra and related technologies. Then our Discord server at bit.ly/Cassandra-workshop, or I would better suggest it again, https datastax.io Discord, and we can answer your questions there. There is a great community. Now, very important resource which will be required at the data modeling part of the exam. datastax.com/learn data modeling by example. That is a very, very important step in the preparation. Let me even send you a link. datastax.com/learn data modeling by example. You will have questions from these parts, so better not miss it. You don't have to work on all the examples, but at least 3-4 you have to analyze and work through. Steps for certification. The idea is very simple. Oh, thank you, Eric. Yeah. Go to dev certifications, read through a material, and take a special note on the exam rules and process session. It is the proctorate exam. It's a real solid certification. With a proctor, you will be watched all through the exam too. That's a very important part. We do it for a reason. We want your certificates to be valuable. So we have a special proctoring company monitoring your as a student, as an attendee of the exam, very, very thoroughly. And there are multiple steps of the check. How do you prove what you are not? Like, there is no one helping you. For example, when I was taking my exam, proctor asked me to show the room with the web camera of my laptop, so he will see what there is no one in the room, what I'm alone, no one is going to help me. And I wasn't ready for that, and my room was a complete mess. And I was like, okay, man, sorry. It's just not, normally it looks better. I wasn't ready for that. So don't be like me. You will have to show your room to confirm you are alone. You are not allowed to eat, drink, listen music, use any electronic devices or books, of course, and so on. So that's a strict exam. Then second step, choose the learning path and take it at the academy. Okay, that's quite obvious. Academy is free. Based on the learning path, complete the course at the academy, get your voucher, and now it is very easy. To get our voucher, you get because you are attending this workshop, you are attending this event today. So just go to dtsx.io cdanz voucher. Again, let me dtsx.io/cdinz voucher https. That is your link. Good. It's a feedback form, so in the best case scenario, you fill it after the Cassandra day is done, because when you can answer the questions properly. Take your exams and we wish you luck. There is a demo DataStax certification online course available at the Academy, but we will do it basically now together. Very easy. No, we won't use Mentium. Now, what do we do? I will ask you those questions. I will give you some time to think about and to give the answer. And then I will show you the right answer and explain what's going on. If you got the right answer, just check the mark, make a mark on your, I don't know, on a paper, on your mobile phone, and you will be good with that. We will have, I don't remember how many questions we have, but not too much, because this workshop has limited time. And I will give you some time to answer. So, okay, I will need my time stopwatch. Okay, timer. Let's get to the first question. Consider the SQL statement. Create table roller coasters, blah, blah, blah. And following inserts into that. 1, 2, 3, 4. Question is, how many rows will the roller coaster table have after executing all the SQL statements? I'm counting time. And you know what? You are the best, so I will even play some music for you. Time is almost over. Boom. Okay, so how many rows will the roller coaster table have after executing the SQL tables? Answer is 3. Sunil Kumar, Kesher Joe, that's the right answer. No, sorry, Sunil Kumar, it's the right answer, not 4. And now let's take a look. Why? Take a look. We create table roller coasters, name, park, rating. Primary key will be name. So we will have as much partitions, as much different values as names we will have, right? And that's all primary key. That's the whole uniqueness. Any write operation in Cassandra, insert, update, and even delete, isn't actually absurd. Let's take a look. Millennium Force, name. Formula Rossa, name. Steel Dragon 2000, name. Millennium Force. Basically, because we use only name as a primary key, Millennium Force is duplicated, and this value, despite insert, it will override the first one. So the right answer is 3. First and 4 inserts are the same primary key that will lead to an absurd. Therefore, only 3 keys created. Get ready for the next question. Consider the SQL statements. Create table song, blah 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 blah. Insert into songs some values, 1, 2, 3, 4 operations. What is the result of executing all those statements? Table with 1 partition, 2 partitions, 3 partitions, 4 partitions. Time is running. And thank you for answering in YouTube chat. That's nice to see what there are people doing job. It's not the real exam, so you won't get your certificate, sorry. But still thank you. Okay, time is almost over. That's it. Okay, time is over. Let's open the answer. Second question has the following story. We will have a table with 4 partitions, and I believe all of you made it. Story is very easy. Yeah, right. We will have so partition key is the first argument of the primary key statement. In this case, we have it in these parentheses. Oh, sorry. Yeah. So it will be artist and title, and therefore here we go and watch for artist and title. Beatles, yesterday. Beatles, let it be. ABBA, Fernando, Frank Sinatra, yesterday. So basically, this one is Beatles, yesterday, Beatles, let it be. If we would have only artist, it would be single partition. But we have also title, 2 partitions. ABBA, Fernando must be clear, and Frank Sinatra, yesterday. Second part is matching, but first part is not matching. Separate partition. So you see, it's very easy. Table with 4 partitions. Well then, consider the SQL statement. Create table cars, blah blah blah. Which of the following is a valid query for the cars table? Time. Time is almost over. Okay, we are getting first answers. First, try to solve it yourself and don't watch YouTube chat because there will be suggestions from others. Time is over. So let's take a look at the answer. Right answer is C, and you all made it. You are getting to that. You see, you already getting better and better. So idea is very simple. First rule, we always have to specify all parts of a partition key. So it's going to be always specified make and model. And in this case, we specify only make, obviously wrong. This time we don't specify make and model at all, so it's also obviously wrong. C looks good. Make, model, and year. Make, model, and year. All good. C is perfectly valid. But now there is an important point, and I see what Adrian also got to this point, and now have a question, mostly probably D, C. Why D is wrong? Because color red is present in the clustering column, and make and model are specified. Why D is wrong? Answer is, there is a first rule about the partition key, which must be present of all its parts. But there is a second rule. If you specify in your search query, in their clause, if you specify a clustering column, they all have to be present from the left to the right in order for query to be executed. So for example, if you do Ford, Mustang, year and color, That will work, but D goes make, model and color. By passing here, that won't work. This query is not valid. Yeah, so partition is mandatory, and clustering column must be in depending on the order, right? From left to right. Okay, let's start. Consider the following SQL statement. Create table employees by department. Begin batch. Insert into employees, blah blah blah, insert into employees by department, blah blah blah. What is a valid statement about this batch? It's a single partition batch what can be applied. It's a single partition batch what cannot be applied. It's a multi-partition batch what can be applied. It's a multi-partition batch what cannot be applied. Meanwhile, Eric gave a very good advice regarding the columns. Yes, you must specify the columns in the order where they appear in the primary key. That's very right. Time is almost over. Very few seconds. I still don't see the answers on YouTube. C, D, C. Any more attempts? Time is over. Okay. C. Adrian thinks it's C. Let's take a look. Yep. Okay, that's the solution. So, first part of this question is very simple. They cannot be partition what is the same within two different tables. That just cannot exist. Partition are always within a table. So first two answers are obviously wrong. Like we have two different partition, we have two different tables in batch. Of course. And right answer is C. That is a multi-partition batch what can be applied. Nothing prevents this batch from being applied, so answer D is also wrong. It's completely valid batch. Let's go for the next one. Consider the table definition with a primary key omitted. Create table reviews by restaurant, blah 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 blah. It's known what restaurant reviews are uniquely identified by a combination of a name, city, and reviewer. Restaurant reviews are retrieved from the table using combination of name, city, and the table has multi-row partitions. So partitions may have multiple rows and it's fine. What primary key does this table have? Time. Okay, there are some answers already. Looks like those answerers agree in their opinion, and time is over. So let's take a look at the answer. It must be quite easy for you. Restaurant reviews are uniquely identified by a combination of a name, city and reviewer. From that we can understand primary key. Restaurant reviews are reviewed from the table using combination of name, city. That obviously follows what at least name or city must be the partition key, right? And table has multi-row partition. Based on that, we obviously see what the right answer is B, as most of you answer it. And Adrian gives the answer B or D, which I want, thank you, which I want to explain separately. Take a look. D is reviewer name city. Which argument goes first? Which argument counts as a partition key? First. In this case, reviewer will be considered as a partition key, which, given these circumstances, are obviously wrong. Combination of name and city must be the partition key. Good. Good. So, yeah, as I just explained, D is the wrong answer, so it's B. Well, let's go to the next one. Now, one more thing for you not to worry about. There is plenty of questions on the exam, but you don't have strict limit 1 minute per question. It's overall general time for the whole exam, and it is enough. Don't be in a rush. So you don't have time to spend 5 minutes on a question, that's for sure. But don't rush, you have enough time to answer all of them. So let's go. Consider the table definition and SQL query. Create table teams, blah blah blah. Select all from teams by wins where wins equal 4. Which materialized view definition can be used to support the query? We nearly didn't discuss materialized views today, so just try to guess. Of course, materialized views are covered in the academy exams, in the academy courses. But Cassandra is big and powerful, we cannot put everything into one single day event. I see no answers so far in YouTube chat. Well, that makes sense. We didn't cover materialized views, but it can be guessed. Okay, time is over, so let's take a look on the answer. Hey, Adrian, yeah, thank you by the way for the question number, it really helps. Wants to guess it as C. David thinks it's D. Cheshire Joe thinks it's C as well, agreeing with Adrian. Let's take a look then. Correct answer is D. Since primary key field cannot be null, their clause must include a null check. Since where clause in the select is based on wins, wins must be partition key. So you see, the point is we have to create MV, materialized views, which will support this query. And this query tries to query data by wins. That means what wins must be the partition key, one and only, otherwise that won't work. So A and C, we drop them because partition key is name. And for wins, we have, so what's the difference? Okay, it's the same, but just without is not null. We cannot build materialized view on null values, so that's how it always looks. We specify wins and name, and that's how it works. So, thank you for answering, and thank you for specifying question number, it helps. Let's go then, question number 7. Consider the table definition and the query. Create table, blah blah blah, select from it. Which secondary index can be used to support the query? Again, secondary secondary indexes are out of scope for today, so it will be harder for you in this case. ordering matters. But in this case, it's simpler when it looks like, actually. In this question, it's easier when it looks. Fifteen seconds. D thinks Jasper. Kevin Orden agrees. Adrian believes it's B. David Lennox agrees with Adrian. Let's take a look. Right answer A. Quite a big surprise. Yeah, Sunil Kumar is right, like the only one this time. The answer is indexes on multiple columns are not supported, so you always have to specify the particular column you want to build index on. In this case, as we want city is already there as it's the partition key, and cuisine sushi is a data column. The answer is simpler, as I said, than it looks like. Create index on restaurant by city cuisine. Boom, it's done. Let's take a look at the next one. Which statement describes the where clause in a query? Where clauses must reference all the fields of the partition keys. Where clauses must reference all the fields of a clustering keys. Where clauses must reference all the fields of a primary key. Where clauses must reference all the fields of a partition key and clustering key. This one must be quite easy for you, because you basically did that already today during the workshop. Okay, Cheshire Joe thinks it's D. Jasper believes it's A. Few last seconds. Adrian thinks it's D. Okay. And C by Sunil Kumar. So this time, let me check. This time it's A. Take a look. Primary key consists of a partition key and clustering column. Partition key parts, all parts of a partition key must present, but you don't have to specify clustering key. You don't need any clustering. You just need a full partition, unsorted or pre-sorted. It's completely fine. You do not have to specify all the fields of a primary key, and you do not have to specify all the fields of a partition key and clustering key, because basically it is the primary key. Right answer is A. Only the fields of a partition key are required. Let's take a look at the next question then. Consider SQL statements. Create type name, first text, last text, create table people. ID UUID, name, email text, primary key, ID, email. Which insert statement can be used to insert a row in the people table? And list of examples. Thing you see right now is a user-defined type. We didn't discuss it today, but in general, user-defined type is a quite powerful thing, so you can pre-create sometimes to use to have your own data types. That's quite cool. And now you just have to try to guess on how do you work with them. And frankly speaking, maybe I should just give you the answer because we didn't cover it today. But try to guess on your own first. Okay, Sunil thinks it's 9A, it's A. What others? Agree, disagree? David agrees. Time is over. It's not so big deal if you're out of time now. We have a pretty tight schedule. Cheshire Joe agrees. One more answer. Okay, everyone agrees it is A. And that is the right answer. Well done, everyone. Okay, almost everyone. No, it is A, not B. For a very simple reason, Cassandra heavily uses and works with JSON. And it's very easy when you work with UDT or with some other types. You just use plain JSON and you are good. So UDT are passed using JSON, and obviously this one is a valid JSON and this one isn't. This one just doesn't match the count. 1, 2, 3, 1, 2, 3, 4 arguments don't match the insert statement definition, and this one is not JSON at all. Let's go further. Consider the following SQL statement. Create table emails by user, insert, update, select. What is the result of executing those SQL statements? Yeah, Adrian, yeah, it's indeed looks like a dictionary or JSON. That's basically, yes, user-defined type. That's exactly how it works. This is a pretty tricky question. Some of you won't answer, and it is completely fine. It's called education. Here you need to know what does static means, and we didn't explain it today. So most of you will fail, and that's not a real fail, but just a part of education. I will explain you based on this example, and time is over. And hey, I see Eric supports you. Yeah, good. So I don't see any answers, and that's quite clear because, okay, there are answers indeed already. C, A. Any more options? We have B and D left. C. Okay, so most of you think it's C, some of you think it's A. Let's take a look. So that is a very important point to understand. There is a static nickname which really changes a lot. Before we proceed, let me explain you about the static. Static field is the field what all the rows within single partition share. It means what if you have partition of 3 different records with some static field, if you update this static field for one of them, it will be updated for all of them. Simple as that. So, and that's the idea, because email is a clustering column, table has 1 partition with 2 rows. That must be clear. Email is a clustering column, table has partition with 2 rows. Like, shouldn't be a big deal here. But nickname field is static, so it was set to Davy for the entire partition. The final update, emails by user set nickname Davy, the username and email, it is always on the, as nickname is static, it will be set for the whole partition. That's why nickname is Davy for both rows, and that's the answer. Now you know. Now you know the answer. So let's proceed here. And I'm sorry, Jesse, I have to ask you to discuss whatever it is with Eric. Not right now because there is a class in progress. So, static can be, by the way, very cool in some use cases and may save you a lot of time. And basically, that's it. There were all our questions. You did good job. We didn't touch administrative exams. Now we will discuss resources. So, academy.datastax.com. We already discussed that. I will better just show the Academy to you. Academy DataStax. Boom. Good. Easiest way to sign in is just sign in with Google or GitHub. Adrian says static means only one. Yes, if you mean one per partition. Okay, and what matters for the Academy is there are catalog. You can find some courses, but what matters for us is paths. Developer path, admin path. You just choose the path and go through it. That's my second account. Actually, I have all of them completed, of course, for actually quite a while, I would say. And you go through those courses. There are practical parts and also much recommended to follow and do. Now, second place, very important. That will be datastax.com/learn. Data modeling by example. You will have questions from this part, I guarantee that. It's a great example on advanced data, on, well, not advanced, but data modeling. You pick any topic, what is most interesting for you. Sensor data, messaging, investment portfolio, time series, shopping cart, order management, and so on. Sensor data, okay. Start modeling. At first, our instructor explains everything. How do you do it step by step? Conceptual data model and how it looks like, entity relationship diagram, application workflow and why it looks like this. Logical data model, what you have in the end, what you create in the end. Physical data model. And then finally, sweet part, you have this start scenario button, which starts code scenario with Cassandra installed for you. And you go to Katacoda, so you can type your commands on the terminal on the right side, or you can simply click these black fields, blue fields on the left. As soon as Cassandra will be started, of course, it takes some time. And then you walk through the practical part of this example. Obviously very useful. Read through it to understand how it works. Hey. And while it's starting, what else I should say? datastax.com/dev certifications. Notice about the rules, because rules are quite strict, and if you break them, Proctor will make you a notice. In case of multiple notices, exam can be terminated. Don't be afraid of the notices. I got a couple of them while taking my exam because I forgot what I'm not allowed to drink or eat. I tried to drink. It's not allowed because maybe you can try to hide some hints for yourself with that. And second, my notice I got because when I think about something, I start to read it out loud, just mechanically. for myself, and it's obviously not allowed as well. You have to stay quiet because maybe you are reading the questions to someone who will help you. So it's not allowed as well. Follow the rules, but it's not like that just boom terminated. You get some notices only if you don't improve on the exam, then it may be some consequences. One more thing for you. I will be happy if you add me on LinkedIn. I can, I don't know, suggest you something about the exam process and so on. And basically, I believe we are done. Let me check what's going on with my schedule. My part is done. And we meet again here in approximately 5 minutes for the closing words, and we will be happy to see you there. It was a long day, but you made it. Just some very last words and we are done for today. Then see you in 5 minutes. take a look. We have quite a good team here in the end. So, how you all doing today? It was a long day and we spent many hours together. So we're happy if you add us on LinkedIn or Discord or YouTube. Don't forget to set the thumbs up because I know you liked it after all of those hours and hours. Just few closing words, very briefly. Cassandra world is great and incredible, and there are plenty of great projects. But this world is lacking something, like for example you. We need more qualified engineers, developers, administrators to be in this world, and that's a big thing. The growth of that is incredible, and how it will be and how many new engineers will be required here is just amazing. So more and more data in the world, and we need good people to handle all of it. You are going to be them. We hope it's been a fun day. We are really thrilled to have you all here. We are happy that you're learning something useful and interesting. You are now ready to power up your applications with Apache Cassandra, but you better first go to the academy, because to complete the education and get your certificate, that really must be the proper word to go and do the things. I will have to do one more thing. Don't forget to send your screenshots if you are the quiz winners to our jack.pryor@datastax.com. I believe I sent you already.
Yeah, I can send it again.
Yes, please. And one more thing is we, I believe, have a winner for the Slack, for the questions and answers. Me, Eric agrees for Johnny with Cassandra Astra for education question, and as soon as Stefano will confirm it, we will have enough voices to confirm that what Johnny made it.
Absolutely. Yes,
Yeah.
I agree. 100%.
That was a good question indeed. So congratulations to all quiz winners and questions and answers winner. That was a great job, and thank you for staying with us for so long time. It was a great time together. Tell us how you would like next Cassandra Day to be. There is a voucher form with the feedback, or also you can catch us on LinkedIn or Discord. Let's keep in contact. For our events, there is a mailing list, datastax.io/subscribe, and that's not a mailing list for all the marketing things you can get from DataStax, but mailing list for the community events.
In particular, our workshops.
Yeah,
which
we
are
run
all around Cassandra.
Yeah, we run usually 2 workshops per week, which also can be very helpful for your career. Maybe not as helpful as Cassandra Days; those are special.
Yeah.
But still can give you a lot. And they are 2 hours only, not a full day event, of course. Join us on Discord. Join us at the community datastax.com for questions and answers. Academy you know already, and YouTube channel DataStax Developers, I believe, already in your subscriptions. Thank you for that. Finally, if you didn't do it yet, go for your voucher and get certified. Get a voucher at datastax.io, CDANZ-voucher. Sorry. And see you at our next workshop.
Yeah.
Sounds good.
Oh, Gesundheit.
Thank you. Yes, good.
Okay.
Let me check if we have.
There's a question about the voucher valid expiration date. starting the moment you redeem it, it has 3 months validity, I think, and it's valid for 2 attempts at an exam. In case you pass the exam on the first try, you can use the second attempt to get the other certification. So you can get developer and administrator. Bam.
Right. By the way, that's perfectly right. Thank you, everyone, especially for those persistent people who stayed till the very end.
Yes.
You are just the very best of the best.
Congratulations.
David, Jasper, Kay Van Orden. That's just incredible to see you staying here for so long with us during this Friday. Have a great weekend.
Thanks, guys.
Have a great weekend.
Enjoy the weekend.
Thank you. See you next time.
See you next time.
Yeah.
And a little bit of music in the end, so you can relax a bit after a huge work done. So have fun and have a great week. Go build something amazing.